Hi, and welcome to the Elementary and Middle School Math Tutor. In this class, we're going to learn about all of the topics that you're going to learn about in elementary and the beginning part of middle school. And those are the absolute core math topics that you're going to be expected to know to move on and go through second, third, fourth, fifth, sixth grade, and so on, okay? We're going to talk about lots of different topics, but the main thing that I want you to realize as we go through this class here is that math is not hard, okay? That is exactly what I really want you to know, and that's what I'm going to show you as we work through the problems. I'm going to teach you how to do math, and it's not going to be very hard the way I'm going to explain it to you. The second thing is, and this is extremely very, very important, is that math is like riding a bike, okay? First time you got on a bike, you probably fell over. The second time you got on a bike, you probably went a little ways and then you fell over. And the third and the fourth and the fifth time, maybe after a lot of practice, you're able to ride up and down the street on that bike, okay? It took practice, okay? The way I'm going to teach you math, and the easiest way to learn math, is to practice, okay? You have to do problems. You have to work through them. It's kind of like learning how to talk. It's kind of like learning how to ride a bike. You've got to work and work and work and work problems. And then, at the end of the day, you'll just know how to do it without even thinking because you will have done so many problems, okay? So that's what we're going to do. We're going to learn the material through working problems. And for the parents that are watching this video with their children, if you feel like the material needs to be watched again, go ahead and just rewind it and play it again. And through the repetition, okay, the skills will just become built one on top of the other, and then moving forward will be much easier. So the first topic we're going to talk about is how to add 1 and 2 digit numbers. And that's where my starting point is going to be. It's going to be how to add 1 and 2 digit numbers. So let's go ahead and do that, and let's do it by working a lot of example problems. Okay, what if you were trying to do something like 2 plus 3? You have to ask yourself first the question, what does this mean? What does addition mean? What does it mean when you add two things together, okay? You should know what the number 2 represents, okay? And that is, if I've got some balls over here, this is 2 balls, 1, 2, right? Pretty easy so far, right? And then I'm going to add to it 3 more balls. So here's 3 more balls, okay? So you can see here that when I put a plus sign here, 2 plus 3, what I'm really trying to ask you to do is if you have 2 balls here and you're adding 3 balls here, how many balls would that equal total, okay? So what you do is you just start with what the first number is and add to it what the second number is. So here you have 1, 2, and if you were to continue counting, 3, 4, 5. So in total, 1, 2, 3, 4, 5 balls. And if you wanted to write that out here, these are all balls, 1, 2, 3, 4, 5. That's what happens when you add these two things together. So 2 plus 3 is going to be 5. Now, let's go ahead and get in the habit in our problems. Even though I initially gave you the problem like this, 2 plus 3 written out to the side, I want you to get in the habit of writing the numbers on top of each other, okay? So this is kind of separate here, on top of each other. And you'll understand why later. Don't really worry about it now, but we're going to add the numbers by putting them on top of each other. But nothing has changed. You just have your 2 balls and you have your 3 more balls, and we've already said that that's going to equal 5 balls, so I'm going to put the 5 right below it. Okay, I'm going to put the 5 right below it. And that's the answer. So on your paper, on your test, you would just circle 5. Okay? Now let's move on and do a different problem. What if you were given 4 plus 2? Again, most of the time the problem is going to be given to you by writing it out to the side like that. Okay? So what I want to do is I'm going to write this problem again as we have done here with the 4 on the top and the 2 on the bottom. And I'm going to put a line with the plus sign. And you will understand a little bit later why we're writing it like this. But for now, just do it. Okay? So if we were going to do this by counting on our fingers or by drawing on the paper, we would start with 4. 1, 2, 3, 4. Okay? And we would add to it 2 more balls. Okay? And so that is what addition is doing. You're taking the first number and you're adding to it by piling on more balls. So if you just start counting 1, 2, 3, 4, 5, 6 balls. So this is going to be 6 balls. okay, over on the end. 6 balls total. And so the answer you would just put underneath the line like this. So 6 is going to be the answer there. Okay? Now another way, the way that I really did this when I was younger, is you can draw things on your paper, okay, if you don't remember what the answer is to adding two numbers together. You can also use your fingers, okay, because you've got 10 nice little fingers here, okay? You've also got some toes. You can use those if you really want to, okay? So if you're going to start with, let's say, 2 plus 3, like this first problem, okay, I have 2 fingers to start with, and I'm just going to add 3 more to it. So I could have, starting with 2, 3, 4, 5, and I end up with 5. So that's what I ended up with in the first place there. As you work problems, and as you get a little bit more experience with working these kinds of problems, and you get a little bit older and you get a little bit more practice, you won't have to use your fingers because you'll just remember the answer. Okay, it's kind of like your ABCs. When you first learned your ABCs, you know, you had to sing that song. Now you just kind of know what they are. Okay, so what if we had a problem with a little bit bigger numbers? 8 plus 5. Okay? Again, all we're going to do is we're going to write this with one number on the top and one number underneath it. And we're going to put a plus sign there. Okay? And we're going to do that, and you'll see why in a little bit. Now you can count on your fingers here. Okay? You can count on your fingers here, or you can just go ahead and draw your balls. Let's draw 8 balls. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 balls. And on the bottom, you can have 5 more balls. 1, 2, 3, 4, 5. Okay? So you have 8 balls on the top, 5 balls on the bottom. So in order to find the answer, all you do is you just add them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 balls. So I'm going to put a 1 here and a 3 here. I'm going to write 13. That is the answer. So from here on out, okay, when you're working problems, when you're adding these single digits like this, okay, you can use your fingers, okay, or you can draw on the board and draw on your paper and arrive at the answer. We're going to be building up in the problems and making them a little more complicated as we go along so we can get some practice. 9 plus 7. Okay? Same thing. We're going to write the 9 on the top and the 7 on the bottom. Okay? And what we're going to do is we can add this up. Now, as you start to get to the bigger and bigger numbers, it gets to be a little bit hard to draw. I mean, it gets a little bit boring to start drawing all these circles on the paper. Okay? You can do that. That works just fine. But if you don't want to do that, you can use your fingers. So how would you do that? Start with 9. We're going to add 7 to it. You should all know that this is 7, okay? So if you start at 9, you would just go 10, 11, 12, 13, 14, 15, 16. You see, we just started at 9 and we continued up to adding 7 more. 10, 11, 12, 13, 14, 15, 16. So that's 16, okay? So the answer is 16. So right underneath here, I'm going to put a 1 here and a 6 here. 16. Okay? Now we could draw 9 balls, and I could draw 7 more balls, and we could count them, and that's fine. But from here on out, I'm just going to use my fingers because handling your fingers are a little bit easier than handling a lot of drawing of circles on the paper sometimes. Okay? Now, as I said, we're going to get into problems that are a little bit more complicated as we go along here. And here is going to be the first example of that. Okay, let's do 11 plus 3. Okay, now you see the only difference between this problem and the last problem is that the numbers are a little bit bigger. It's really the same concept though. So what we're going to do is we're going to put 11 on the top and 3 on the bottom. Okay, and we're going to put a plus sign. Now notice in all of the other problems before, they were single digits, so I just put the numbers on top of each other like this, okay? Now, in this problem, when I have a double-digit number on the top and a single-digit number on the bottom, I'm going to write the double-digit, I'm going to put the bigger number on the top and the smaller number on the bottom, and I'm going to push the number off to the right and kind of align them like this. So the 3 is going to go under here. And you'll see that as we do more and more problems. Now, certainly, you could draw 11 balls out, okay? and you could draw 3 more balls here, okay? And you would get the exact correct answer, okay? But well, we can do that now, and we can see where we go, okay? What we're going to do is we're going to start with 11, and we're going to add 3 more to it, okay? So let's start with 11, let's add 3 more to it, let's see what the answer is going to be. Starting at 11, 12, 13, 14. We added 3 more. We'll do it again, starting at 11, 12, 13, 14, okay? So it's going to be 14. So I'm going to write 14 right under here. And that is the exact correct answer. And we did this by counting, okay? But now I'm going to begin to show you the real way in which you add these things together, okay? Because as you will see, the bigger the numbers that we have here, the harder it's going to be to use your fingers, okay? Eventually, if I start to add big numbers together, like 47 plus 24, it's going to be very hard to use your fingers, okay, to actually add those together. You could do it, but it would be much harder. So what I'm going to do now is I'm going to teach you a really cool, really quick way to do this. So here we did this by counting. And that's perfectly fine way to do it, okay? Perfectly fine way. But here's another way, and this is the way you're going to have to become good at. We put 11 and a 3, and we put a plus like this. And this is why I want you to line them up on top of each other with us. If you have a smaller number, push it over to the right so it's aligned. This is how you do it. You start in the right-hand column first. So we're going to be working right to left, okay? What you want to do here is just forget about the fact that this is a number 11. Just look at this 1 and look at this 3. What's 3 plus 1? I think you should know 3 plus 1 is 4. So just write a 4 directly underneath these two numbers that you added together, okay? So now you're done with this column, okay? Now move over to the next column. You have a 1 here, and there's nothing written down here, so this is like a 0. So 1 plus 0, which is just right here because there's a blank, 1 plus 0 is 1. So you put a 1 down. Now notice we got 14 in the answer here, and we got 14 in the answer here. We got the same answer, and that's good because that means we did the right thing, okay? So you can always count on your fingers if you want to, but as we move up into the bigger problems with bigger numbers, you're going to have to learn how to do it this way. So just start right to left. 3 plus 1 is 4, and then so you're done with that one. And then you move over here. 1 plus 0, because it's blank, gives you a 1. So the answer is going to be 14. And the rest of the problems that we're going to have here in the 2-digit addition problems are going to be practicing that. And they're going to get a little bit more complicated, but really they're not going to be any more complicated than that. It's really not that hard. If you know how to add numbers up from 1 to 10, then you'll be able to do this. So let's say you have 13 plus 4. Okay? Again, the very first thing you do is write the bigger number on the top, 13, the smaller number on the bottom, and I'm going to push it to the right so it lines up on the right, put a plus sign, okay? And I want to add these up. Now again, you could write 13 circles on the board, and you could write 4 more circles, or you could use your fingers and you would get the correct answer. But let's do it this different way. Let's work in the right-hand column. 3 plus 4 you should be able to do fairly fast, or maybe use your fingers. Starting with 3 and adding 4 more is 4, 5, 6, 7. We added 4 more. So we get a 7 here. 3 plus 4 is 7. So we put a 7 directly underneath those numbers. So now we're done with that because we've added that up. Now we move over to the left. 1 plus 0, because there's nothing here, it's like a 0, just gives you 1. So the answer is 17. You start at the right, 3 plus 4 is 7, and then you move left. 1 plus 0 gives you 1. Okay? We're just going to do a lot of these problems so we can get a lot of really good practice. 15 plus 4. What's the first thing you do? You write the bigger number on top, you write the smaller number on the bottom, and push it to the right so it lines up on the right. Okay? And you have to have your plus sign, okay? And we're going to start in the right-hand column. 5 plus 4, you can do that either in your head or you can do that on your fingers. 5, 6, 7, 8, 9. So 5 plus 4 gives you 9. like this. 5 plus 4 gives you 9, and you're done with that column. Now you move left. 1 plus 0 just gives you 1. So the answer there is 19. Okay? The answer there is 19. Okay? So you see it's not too bad. You just start on the right and work your way left. And just add the columns up as you go. And addition just really becomes very easy at that point. Okay? So let's try one a little bit different. 12 plus 7. Okay? First thing we do is we put the bigger number on top, put the smaller number on the bottom, and we push it to the right so it's lined up on the right. Okay? And we start in this column. 7 plus 2 will give you 9, right? Because 7, and then you add 2 more, gives you 8, 9. We added 2 more, so that gave us 9. Put a 9 directly underneath there. We're done with that column. Now here, it's 1 plus 0 gives you 1. So the answer is 19. Okay, now we're finally building up to the more challenging problems, and this next one is very, very important that you understand, okay? 17 plus 5. Doesn't look too different than this problem, so let's just keep on going and see what happens. Write the big number on top first, 17, okay? And the small number on the bottom. We're doing everything exactly the same as before, okay? Now, let's go ahead and work in the right-hand column first. 7 plus 5, what does that equal to? You can use your fingers, okay? 7 plus 5, 7. Let's continue. 8, 9, 10, 11, 12. So 7 plus 5 gives me 12. Now, the thing you need to realize here is that even though 7 plus 5 is 12, you do not put 12 down here. That is not the right thing to do. Do not do that. Basically, the rule is when you're adding numbers up like this, okay, if the number is a single digit, you put the single digit down there. If it's 2 digits like it is here, you have to do something a little bit special. And I'm going to show you that right now. Okay, 7 plus 5 is 12, so I'm going to put the 2 down here for the 12, okay? But I'm not going to put the 1 right next to it. I'm not going to put the 1 right next to it. I'm going to put the 1 up here in the next column over. So what you have is 7 plus 5 is 12. You put the right digit down, the 2 here, and then the 1 that you need to write somewhere, right? You have to put the 1 somewhere. Do not put the 1 here. Put the 1 above the column to the left. So I'll put a 1 here. Okay? Now, you're done with that column. Okay? You're done with adding 7 plus 5. Let's move over. You have a 1 here, you have a 0 here, but I just put this 1 here, so we need to add these two together. 1 plus 1 gives you 2. So the answer is going to be 22. And we're going to do a lot of problems to reinforce this, but what you just need to do is you start in the right. 7 plus 5 gives you 12. If in this case the answer is 12 for that first addition, so because it's not a single digit, because it's a double digit, you put the right-hand digit down, and then you put the digit to the left up above, the 1 here. And then you just go to the next column and you add up everything here, okay? All right, so let's move on. Let's do some other problems. We're going to build on that, and we're going to get so good at that it's just going to seem like second nature. What about 19 plus 7? Okay, 19 plus 7. Well, you write the bigger number on the top and the smaller number on the bottom, just like before. Okay, and just like before, we're going to add the right-hand column. 9 plus 7 gives you, and you can count your fingers, it's going to come to 16, okay, because starting at 9, 10, 11, 12, 13, 14, 15, 16. It's going to be 16, but I do not want to write 16 down here, okay? I do not want to write 16 right here. I want to put the right-hand digit, the 6, and then I'm just going to put the 1 up here. So I have to write 16 down somewhere, but anytime you add these two things up and it becomes a 2-digit or a 3-digit or a 4-digit number, anything greater than 1 digit, if it's just 1 digit, I just put the 1 digit down. But in this case, it's 16. So because it's 2 digits, I put the right-hand digit down here, and then the other digit, I just put it in the next column, and I put it up above. So now we move over to the left, and we continue adding. 1 plus 1 gives me 2. So the answer is 26. Okay, so in the first part of the problems, when I'm adding that rightmost column, okay, I got a single digit answer, so I just wrote it down there. If you ever add something up like this and get a double digit number, you just write that right hand digit down, and then the left digit, you just put it on top in the column to the left, and then keep adding. Okay? Now, what if you had something like a little bit more complicated, like 12 plus 11. So this is the first problem where we have a double digit plus a double digit. But you're going to find out that the rules are exactly the same. It's very, 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 very easy. 12 plus 11. I just write number on top and number on bottom, okay? Now how do I add this, okay? Start in the right-hand column just like before. 2 plus 1 should give you 3. That's a single digit answer, so I just write it down. I don't have to do any of this business because it's just a single digit number, okay? You're done with that column. Now move to the left. 1 plus 1 just gives you 2. So the answer is 23, okay? So you see, adding single digits to double digits or adding double digits to double digits, it's really all the same thing. You just start on the right and then add 2 plus 1 is 3. You're done. Then 1 plus 1 is 2. And again, you're done, okay? And you're going to find out that the rules of addition are not that difficult. You just practice, 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 practice. Okay, what if you had 15 plus 16? Okay, double digit plus double digit. So you have number on the top, number on the bottom. First thing you do, write them on top of each other. And this is exactly why I asked you in the very beginning to go ahead and get in the habit of writing your numbers on top of each other. So you start in the right-hand column like this, and you say 6 plus 5 is what, okay? When you do that on your fingers, 6 plus 5, let's go ahead and do it. 6, now let's continue. 7, 8, 9, 10, 11. I added 5 more to it. That gives me 11. Now 11 is a double digit number, so I don't want to write 11 down here. I'm going to put the rightmost number here, which is a 1, and then the other one I'm going to put up here. This is a little mark up on the top, okay? So I wrote 11 down, okay? I'm done with that column. Now I just have to add this column. 1 plus 1 plus 1 gives you 3. So when you write your digit down up here, you have to make sure and add it in like this. So you're going to get 31. So 5 plus 6 is 11. Put the right digit down, put the left digit up here. 1 plus 1 plus 1 gives you 3. Okay? Now what if you had 17 plus 18? Same thing. Write the number down on top, write the number down on the bottom, and add them together. And what you want to do is start in the right-hand column here, 8 plus 7, okay? What is 8 plus 7 going to be, okay? It's going to be starting with 8, 9, 10, 11, 12, 13, 14, 15. I added 7 more. It gives me 15. 15. Now, 15 is a two-digit number, so I don't just want to write 15 down. I'm going to write the right-hand digit, which is a 5, okay? But I got to put that 1 somewhere, the 1 that goes in 15, and I want to put it down here, so I'm going to put a 1 right up here, okay? Anytime it's greater than 2 or greater digits, I put the other digit up here. Now we're done with this column, so let's move and add these up. 1 plus 1 plus 1, just like before, gives you 3. So it's going to be 35, okay? 35. Now these problems aren't going to get really any more complicated. I'm just doing a lot of them to give you practice. But the rules, they're not going to change. They're really the same. So what if you had 23 plus 16? Okay, 23 plus 16. Double digit plus double digit. Let's write 23 on the top, okay, and 16 on the bottom. And we're going to have our plus sign. So again, the same thing happens. You start in the rightmost column, and you say 6 plus 3. Well, starting with 6, 7, 8, 9. Added 3 more, we got 9. So 9 is going to be in this column. We're done with that column. Now let's move over. 2 plus 1 gives you 3. So the answer is going to be 39. And there's nothing else to do. You just start in the right-hand column. 3 plus 6 is 9. And then move over. 2 plus 1 is 3. Now you can see right now that this is much, much easier than counting all of this on your fingers, because then you would have to put 23 circles down and then 16 more circles down, and you have to count them all up. And this turns out to be much, much better. Okay? What if you had 24 plus 19? How would you do that? Well, you'd write the first number on the top, okay? And then you'd write the 19 underneath it, and you'd want to add them up, right? So you would start in the right-hand column, and you would say 9 plus 4. What would 9 plus 4 equal? Well, you can do that on your fingers, starting at 9, 10, 11, 12, 13. Okay, 13. I added 4 to it, got 13. But 13 is a double-digit number, so I don't want to just write 13 down. I want to put the 3 over here. Now, I've got to put the 1 somewhere. I'm not going to put the 1 down here. I'm going to put the 1 up here. So 4 plus 9 is 13. I'm going to put the 3 here and the 1 up here in the column to the left. Now we're done with that. Let's move over here. We've got 1 plus 2 plus 1. Okay? So 1 plus 2 is 3. 3 plus 1 is going to give me 4. So I'm going to put a 4 down here. 1 plus 2 plus 1 is going to give me 4. And you can do that on your fingers and figure that out. And so the answer is going to be 43. Okay? Now we're going to just do one quick final problem in this section. It's not going to be really that hard. What if they gave you something like 6 plus 17 plus 10? Okay? How would you add that up? You've got 3 numbers to add instead of just 2, but you're going to find out that it's really no different, okay? It's really no different. So what we want to do is we want to write down, let's put 10, and let's put 17 under it, and let's put 6 under it. Now the reason I wrote it this way is because basically you want your smallest number to be on the bottom or underneath, and you want it pushed over to the right, okay? So make sure that the numbers with the most number of digits is on the top, and the numbers with the least number of digits is on the bottom, okay? So here we just start in the right-hand column, and we say 0 plus 7 plus 6. Well, 0 you don't have to worry about. So what's 7 plus 6? And you can do that on your fingers, starting at 7. 8, 9, 10, 11, 12, 13, okay? So that's going to give you 13. But 13 is a double-digit number, so I don't want to write it down there. I'm just going to put the 3 down underneath this column, and I've got to put the 1 somewhere, so I'm going to put the 1 up here, okay? Now I've written 13 down, okay? And now we're done with that column. We just move over. 1 plus 1 plus 1, there's a 0 here, so that doesn't count, but 1 plus 1 plus 1 is just going to give you 3. So the answer is going to be 33. So when you're adding 1 or 2 digit numbers, the only thing you have to do is start in the right-hand column. You put your numbers up on top of each other, start in the right-hand column, and add that up. If the number is just 1 digit, you just write it down, and you move over to the other column and keep going. If that number is 2 digits, you just write the rightmost number down of whatever it was that you came to, put the left number down up here, and then when you go to the next column, you add that number up with it. And that is how you add 1 and 2 digit numbers together. Hi, and welcome to this section of the tutor where we're going to learn about how to add 3 and 4 digit numbers together. Now the good news is if you just watched the previous section of the course and you know how to add 1 and 2 digit numbers together, then this, even though it looks harder, is not going to be really hard because it's the same rules. There's nothing new here. The only difference is that the numbers are going to look a little bit bigger. So let's go ahead and do some problems, and I'll show you how to add 3 and 4 digit numbers together. What if you had the number 124 plus 38? Now I'll admit to you that this problem looks a lot more complicated than the ones that we were doing in the last section, but I'm going to show you now that it really isn't, okay? Same thing. Let's go ahead and write the numbers on top of each other, and we want to put the bigger number on top. 124 has more digits, so it goes on the top. 38, we're just going to write it like this, and just like before, we're going to push it over to the right so it lines up with the right-hand column. Okay, now the same exact rules apply. Start in the right-hand column and add these 2 things together. 8 plus 4 gives you 12. And if you need to use your fingers for that, that's fine. You can start with 8, 9, 10, 11, 12. So we added 4 to it, we got 12. But 12 is 2 digits, so we can't just write numbers that are 2 digits down here. So we put the 2 down, okay? And we have to put that 1 somewhere because after all, we're trying to write 12 down. We're going to put the 1 up here in the column over to the left, okay? So it's the same thing as before. Now we add this column. 1 plus 2 gives me 3. 3 plus 3 gives me 6. So I put 6 down here. So all you're doing is adding these numbers here. Again, 1 plus 2 is 3. So that's these two. And then 3 plus another 3 gives me 6. Okay, and I just write it down in that column. Now I'm done with that. Now I just move to the left and say 1 plus 0, just like before, gives me 1. So the answer is 162. It looks like a harder problem, but it really isn't. There's just one more column to deal with. And it's the same rules as before. Okay? What if you had 210 plus 106? Okay? Well, what you want to do is write these on top of each other, 210 and 106 on top of each other, and put a plus sign, okay? And it's the same thing as before. We're going to start on the right-hand column. 6 plus 0 is really easy because that just gives you 6. Anything plus 0. Anything plus nothing is just going to give you itself back, okay? So 6 plus 0 gives you 6. And look here, we have in the next column 1 plus 0. Again, it's just going to give you 1 because anything plus a 0 is just going to give you itself back. And we're done with that. And then we move to this column. 2 plus 1 is just going to give us 3. So the answer is 316. So you can see this problem looks a whole lot more complicated than the problems in the last section. It looks a lot more complicated, but once you know how to do it, it doesn't become that complicated. And that is what I'm going to be teaching you throughout the whole course here, is that things that seem complicated really aren't. Okay? So what if you had 378 plus 219? Okay? Again, looks more complicated, but all we're going to do is we're going to write these numbers on top of each other, 378 and then 219. And we're going to add them up. Okay? I'm going to start in the right-hand column, and I'm going to add 9 plus 8. And you can do that on your fingers, or maybe you might know that one already, but if you start at 9, and you go 10, 11, 12, 13, 14, 15, 16, 17. Added 8 more, and I got 17. But 17 is too big to put down here because it's 2 digits, okay? So I'm going to put the 7 down, okay? The rightmost digit I'm going to put down. And I've got to put that 1 somewhere because I'm writing 17, so I'm going to put the 1 up here, okay? So I wrote 17 down, okay? Now we move to the next column. 1 plus 7 gives me 8, and then 8 plus another 1 gives me a 9. So you're just adding this up. 1 plus 7 gives me 8. 8 plus 1 gives me 9. I write that down. It's a single digit, so I can just put it down there, okay? Now I'm done with that column. I move to the left. 3 plus 2, you could probably do that one on your fingers, it gives you 5. So the answer is 597. Okay? And what if you had 487 plus 267? Again, these are getting to be pretty big numbers, but as we can see, it's really not that hard whenever you know the rules. Okay? And that's going to be exactly true. So we just write them on top of each other, and we start in the rightmost column. 7 plus 7, you can do that on your fingers. It's going to be 14, okay? And let's see that. 7, 8, 9, 10, 11, 12, 13, 14. So I added 7 more, and I got 14. So I put the 4 there, and I've got to put that 1 somewhere, and I know I'm not going to put it down here, so I've got to put that 1 up here. Okay? So I wrote 14 down. Okay? So now we move to the next column. 8 plus 1 gives me 9, and 9 plus 6, 9 plus 6 is going to be 15. And if you want to use your fingers for that, you start with 9, 10, 11, 12, 13, 14, 15. Okay? Okay, so 1 plus 8 is 9. 9 plus 6 is 15. Again, it's 2 digits, so I can't just write it down. I put the 5 there, and I've got to put that 1 somewhere. Where do you think it's going to go? It's going to go up here. Okay? So anytime you're writing a double digit down like this, you got to put the leading number up on the top of the other column. Okay? Just like we did here. So now let's move to this column. 4 plus 1 gives me 5, and 5 plus 2 is just going to give me 7. 5 plus 2 is going to give me 7. Okay? So 754 is the answer. Now this was a little bit more complicated problem, but it's very, very, very easy because 7 plus 7 gives you 14. I write the 4 down, put the 1 up here, and we move to the next column. When you add all these up, it comes to 15. Put the 5 down, put the 1 up here, okay? And then you add these up, it comes to 7. Okay? And you're going to see here that as we put bigger and bigger and bigger numbers on the board, the problems are going to look a lot more complicated, but the solving of the problems isn't really going to be that much more complicated. So what if you had 1, 2, 4, 9 plus 3, 8, 4. This is 1,249 plus 384. So what you would have is they have the big number on the top, 1, 2, 4, 9, the smaller number on the bottom, 3, 8, 4. And of course you want your plus sign. Now, even though it looks a lot more complicated, you do the same exact thing as before. No different. You start in the right-hand column and say 9 plus 4. 9 plus 4 is going to give you 13. If you start at 9, 10, 11, 12, 13. Okay? But 13 is a 2-digit number, so you can't just put it down here. You put the 3 here, and you've got to put that 1 somewhere, and you put it up here. Okay? Now, you're done with that. Move on to this column. Okay? 1 plus 4 gives you 5. 5. 5 plus 8, okay? 5 plus 8 is going to give you 6, 7, 8, 9, 10, 11, 12, 13. Okay? So this is going to be 13. Again, 13 is too big just to write down here. It's 2 digits, so you have to put another 3. You have to put the 1 somewhere, so the 1 is going to go up here in the next column. Now you're done with this. Move on to this column. 1 plus 2 gives you 3, and 3 plus another 3 is going to give you 6. Okay, you're done with that column. Finally, you have this 1 plus a 0, because there's nothing there, and that's just going to give you 1. Okay, so in the end, you're going to get an answer of 1,633. And you see, even though it looks more complicated, it's really the same. You start in the right-hand column, you add, we got 13, put a 3 and a 1 here, added this up, got another 13, put a 3 and a 1 here, add this up, got a 6, and add this up and got a 1. So really, the only thing is to know where to put these numbers whenever you have a 2-digit number that you have to write down. And that's why we're doing a lot of these problems, is to show you that. Okay, what if you had 2, 7, 2, 6 plus 3, 1, 4, 1. So this is the big number here, 2,726 plus 3,141. Okay, but again, it's exactly the same thing as before. We want to write them down on top of each other, and we want to line up the columns. Okay, so we write them on top of each other. And we start in the right-hand column. 6 plus 1 gives me 7. Okay, so we're done with that. 2 plus 4, if you do that, you should see that gives you 6. Okay, we're done with that. 7 plus 1 gives you 8, and we're done with that. 2 plus 3 gives you 5, and we're done with that. So every time we did an addition here, we got a single-digit number, so we just put them down. We didn't have to do any of the other business because they were all single-digit numbers. So the answer is 5,867. Okay? Now, what if you had 6729 plus 1897. 6,729 plus 1,897. Well, you would have 6729 on the top, and you would have 1897 on the bottom. Okay, so we're just going to go ahead and write those down. And we're going to start in the right-hand column. 9 plus 7, what is 9 plus 7? That's going to be 16, because you start at 9, 10, 11, 12, 13, 14, 15, 16. We added 7 more, we got 16. But 16 is too big just to write down here because it's 2 digits. So we put the 6, and then we got to put that 1 somewhere, so we just put it right up here in the next column. Okay, now we're done with that column. Now let's move over here. 1 plus 2 gives you 3, and 3 plus 9 is going to give you 12, and you can just start with 9 and go 10, 11, 12. 3 plus 9 is 12. So what we're going to have is a 2 here, and we have to put that 1 somewhere, and it can't go here. We're writing a 2-digit number, so it's going to have to go in the next column. Okay? Now we're going to add all these up. 1 plus 7 gives you 8, and 8 plus another 8 is going to give you 16, because starting with 8, 9, 10, 11, 12, 13, 14, 15, 16. So we added another 8 here, and we got 16. Put a 6, and we can't put that 1 down here because it's 2 digits, so that 1's got to go somewhere. It's got to go up here in the next column. So now we work on the next column. 1 plus 6 gives me 7, plus another 1 gives me an 8. Okay? So it's 8,626 is the answer. And you see it's really not that difficult. It's just a matter of knowing how to add single-digit numbers together, and then you can kind of go from there. 9 plus 7 gave us 16. Put the 6 here and the 1 up here. 1 plus 2 gave us 3, plus another 9 gave us 12. So we put the 2 here and the 1 up here. And then 1 plus 7 gave us 8, plus another 8 gave us 16. 6 goes here and the 1 goes up here because that was a 2-digit number. And then 1 plus 6 gave us 7, plus another 1 gave us 8. And then we're done because we've used all our columns up. So you just start in the right-hand column and work your way left. And when there's no more numbers to write down or to add, then you're done. So what if you had 1, 2, 3, 9 plus 2, 3, 4 plus 4, 7, 0, 2. So we're adding 3 numbers here, and we have 4 digits, 3 digits, 4 digits. So we want to write the most number of digits on the top, okay, and the least number of digit numbers on the bottom. So let's write 1, 2, 3, 9, and then let's write this one, 4, 7, 0, 2, and let's write the least number of digits on the bottom, 2, 3, 4. And we're going to add these up. Okay? But the rules are exactly the same. You start in this column and you start adding. 9 plus 2 is going to be starting at 9, 10, 11. Okay, so that's 11. Plus 4 more, 12, 13, 14, 15. So that's going to give us 15. But 15 is too big to write down here. So I'm just going to put 5. And that 1's got to go somewhere. And I'm not going to put it here, so I'm going to put the 1 up here. Okay? Now let's add this column. 1 plus 3 is 4. 0 doesn't add at all. So 1 plus 3 is 4, plus 3 more, starting at 4, 5, 6, 7. We added 3 more and we got 7. So this is going to be 7. It's a single digit, so I'm just going to put it down there. Now let's go in this column. Okay? 2 plus 7 is going to give me 9, because starting with 7, 8, 9. Okay? And then 9, and then adding 2 more, 10, 11. That's adding 2 more. It's going to be 11. So I'll put a 1 here, and the other one's going to have to go somewhere. So the other one's going to go here. So 2 plus 7 plus 2 gave me 11. 1 digit goes here, 1 digit goes here. Now let's add this column. 1 plus 1 gives me 2. 2 plus another 4 is going to give me 6, because starting at 2, 3, 4, 5, 6. Added 4 more and got 6. So I'm going to put a 6 down here in the answer, 6,175. So you can see that no matter how many numbers you're trying to add up, no matter how many digits they are left and right, no matter if you have a number this long and this many digits, it's the same exact rule, okay? You start at the right, you add them up. If it comes out to a single digit, you just write it down and move on. If it's 2 digits, then you put the right-hand digit down and carry the left-hand digit over. And then just keep adding and doing the same thing over and over and over again. And that is how you add numbers that have 3 and 4 digits, or in fact, any number of digits in length. Hi, and welcome to this section of the elementary and middle school tutor, where we're going to learn about subtracting 1 and 2 digit numbers. Now, it's very similar to addition. The only thing that you need to really think about is that subtraction is the opposite of addition, but you'll see that as we start to work from the right-hand column onto the left, it's very, very similar. We just need to go and learn about a little bit about subtraction, and we'll learn about the differences along the way, and we'll work some problems. So let's go ahead and learn how to subtract 1 and 2 digit numbers. What if you had 5 minus 2? Now this is what we call subtraction. So instead of adding these two together, we're going to take the difference, okay? Now what that means, though, is that if you had 5 balls to begin with, 2, 3, 4, 5, okay? And I'm going to subtract 2 balls from it, okay? Okay, here's the 2 balls here. What I'm really doing here is I'm basically going to subtract 2 balls from the 5. So I'm going to take 1 ball away, 2 balls away. I'm going to take them away. They're gone. I've given them off to my grandmother, okay? I don't have them anymore. I had 5 to begin with. I took 2 away. How many do I have left? That is what subtraction is, okay? Now you can see that in this case you have 3 balls left. So the way you would write this is a 5 on the top, a 2 on the bottom with a subtraction sign, okay? And then you would write down the answer just below here, and that would be a 3. Now you can write your balls down and you could scratch off numbers, and then you would be able to find the answer. But just like in addition, it's going to be difficult. It's going to be hard to do, because if you have like 34 balls, I mean, you have to write all these on the board. So you can learn and do what I'm going to teach you here, and that's going to be, for small numbers here, you could just start with 5, like in this case, take 2 away, 1, 2, and how many do you have left? Well, you have 3. So then we knew we could put the 3 down here. Okay, so what we're going to do here is we're going to work some problems with subtraction of 1 and 2 digit numbers. Now let's say you have 7 minus 5. Now I could put 7 balls down, okay, and we could take 5 balls away, but what we're going to do is we're going to write them on top like this, okay? Okay, so you start with 7, and then you want to subtract 5 from it. So you just go backwards, okay? You start with 7, we're going to take 5 away. So starting at 7, 6, 5, 4, 3, 2. We took 5 away, we got 2 is the answer. So 2 is going to be here. And that's exactly the answer, okay? Now notice that you can go ahead and draw your balls. 1, 2, 3, 4, 5, 6, 7. Okay? And we start with 7, and you can take 5 of those balls away. 1, 2, 3, 4, 5. Okay, we took 5 away. We have 2 left. Okay, that's fine. That's exactly right. But you'll find that as the numbers get bigger and bigger, it's going to be hard to write all these on the board, and so I'm trying to teach you how to use your fingers there and help you out. Okay, now you can kind of think of subtraction as the opposite of addition, and that is in fact exactly what it is. Okay, what if you had 10 minus 7? 10 minus 7, okay? Well, first thing we want to do is we want to write the numbers on top of each other, just like before. We're going to put a subtraction sign, okay? Now let's go ahead and use our fingers here. Starting at 10, we're going to take 7 away. Starting at 10, 9, 8, 7, 6, 5, 4, 3. So we took 7 away, and we're going to have 3 in the end, okay? So we did this using the counting method here, counting. So that's exactly what we did there. Now let's go ahead and do another problem, and I'm going to start to teach you the real way in which you're going to do subtraction when the problems get a little bit harder. 15 minus 4, okay? We're going to write that the same way, 15 on the top, 4 on the bottom, subtract. Now, we could take 15 and start to subtract 4 away. So 14, 13, 12, 11. Okay, we're going to have 11. So we know the answer is going to be 11. But what we're going to do is we're going to start to do it kind of like we did the addition. We're going to start in the right-hand column, and instead of adding these two together, because that's what you do when you add things together, we're going to subtract them. Start at the top number, subtracting the bottom number. 5 minus 4 is just going to give you 1. And to convince yourself of that, if you start with 5 and you take 4 away, well, you only have 1 left. Okay? So you just put the 1 there. It's a single digit, so you can just put the 1 there. Okay? And then here, we're done with this column. Now in this column here, you've got 1 minus 0. Anything minus 0 is just going to give you itself. So you're going to have another 1 here. So the answer is going to be 11. And that's exactly what we got when we did the counting method, which means that we did it right. Okay? Which means that we did it right. So let's go ahead and work up some examples that are a little bit harder so we can learn how to do these. 18 minus 7. How would you do that? You write your 18 on the top and you write your 7 on the bottom. Okay? Just like before. Whoops, except we're not doing any addition, we're doing subtraction. Okay? You start in the right-hand column and you say 8 minus 7. So this is a bigger number minus a smaller number. 8 minus 7 is going to give you 1. Because if you have 8 pencils and you take 7 of them and you throw them in the trash, how many do you have left? Well, you have 1 left. Okay? So you put a 1 down. You're done with that column. Now here, 1 minus 0 gives you 1. Okay? Again, the answer is going to be 11. So you can kind of start to see a pattern and a relationship here between addition. You start in the right-hand column and you work left. Okay? You work left. And you just write the numbers down as you subtract them. Now this next problem is going to be a little bit different. You need to make absolutely sure you understand this next problem. 24 minus 6. Okay? So you write your 24 on the top, you write your 6 on the bottom, and you're doing a subtraction. Now what you want to do again is you start in the right-hand column, okay, and you want to say 4 minus 6. Now the first thing that you should realize or think about is usually when you're doing subtraction, like 5 minus 4 gives you 1. 5 minus 1 gives you 4. 5 minus 3 gives you 2. You always start with the bigger number and you subtract the smaller number from it. Okay? That's what subtraction is. You have 10 apples. You throw 5 apples in the trash. How many apples do you have left? You have 5 apples left. You start with a bigger number. You throw some of them away. You're subtracting them. Okay? And then you have some left over. Okay? But here, if you start in this column and you have 4 minus 6, you're starting off with a smaller number. 4 is smaller than 6. So if you only have 4 apples and you're trying to take 6 away, what do? The answer is you can't do this exactly like it's written here. Anytime you have a smaller number on the top and a bigger number on the bottom, you have to borrow. Okay? Fortunately, you can borrow from the bank here. Okay? What I'm going to do is I'm going to put a little 1 here next to the 4 because I'm going to borrow some points away from the 2 here. I'm going to scratch through the 2 and I'm going to put a 1 here. Now let me explain what we did here. We borrowed. Okay? We took 1 away from the 2. Okay? We took it out of the bank. So this 2 is no longer there in the problem. It is now 1. Okay? But since we borrowed, we added some numbers to the 4 here and we added 10 more. So we put a 1 in, so we have a 14. So we've changed the problem now. You have 14 minus 6, and now you have 1 minus 0. And I know that that may not make a whole lot of sense, but as you work a lot of problems, you'll get the hang of it. Okay? So in the end, what we want to do next is we want to take 14 and subtract 6 from it, which we can do in our fingers. 14, starting at 14. 13, 12, 11, 10, 9, 8. Okay? Means we're going to have 8 left. Okay? And now we're done with that column. Now we have 1 here. Remember, this 2 is no longer there. That's why I drew a line through it. We have a 2. We have a 1 left. So 1 minus 0 gives me 1. So the answer is going to be 18. Now real quickly, I want to go over it one more time to make sure you're clear. In the original problem, 4 minus 6, you don't know how to do it because you have a smaller number on the top. We have to make that number bigger somehow. So how do you do it? You borrow from the bank. You put a 1 next to it, and this is not 4 plus 1, this is a 1 next to it, and that makes it a 14. But that 1 has to come from somewhere. So you put a line through the number to the left, you just put a line through it, and then you make it 1 less because you're borrowing 1 from it. So 2 minus 1 gives you 1, that's why it's a 1 here. So we took 1 away from this column, and we gave it to this column. That's all we did. We borrowed from the 2. We took 1 away from this column, and we put it in this column. And so making this 14, now we have a bigger number on the top. 14 minus 6 gives you 8, and then 1 minus 0 gives you 1. Okay, let's move on and do some other problems. Okay, 27 minus 11. Okay, we just want to write the 27 on the top, the 11 on the bottom with a subtraction. Start in the rightmost column. 7 minus 1 gives you 6, okay? And then you're done, so you move to the left. 2 minus 1 gives you 1. So the answer is 16. We didn't have to do any borrowing because each number was bigger on the top than it was on the bottom. Okay, what if you had 34 minus 27? Okay, first thing you want to do is you want to put the 34 on the top, that's the bigger number on the top, and then you want to put the 27 on the bottom, which is a smaller number on the bottom. You want to start in the right-hand column and try to subtract 4 minus 7. Here you have the same problem as before. 4 is less than 7, so you can't do that. You have to have the bigger number on the top. So how do you do that? You borrow from the bank. So what we're going to do is we're going to borrow 1 from this column, so I'm going to put a line through the 3, and I'm going to make it a 2 because we borrowed. But since we're going to borrow from it, we're just going to put a 1 here. So what we did is we borrowed from this column and we gave it to this column. So we made this a 2 and we put a 1 in front here to make this a 14. Okay, we borrowed from this column, we gave to this column. So 14 now minus 7 is just going to give you 7, and you can do that on your fingers starting at 14. 13, 12, 11, 10, 9, 8, 7. Okay? Gives you a 7. And then 2 minus 2 gives you 0. And I don't even need to write the 0 down. You certainly can. You could put a 0 here if you want. But anytime the 0 is in front, it really just doesn't mean anything. So the answer is 7. Okay? So in this case, we had to borrow 1 from this column and give it to this column to make this a 14 so that we could do the subtraction. So basically, anytime you're working on subtraction, you have to have a big number subtracting a smaller number from it. It's the only way it's going to work. And if you don't have that, you're going to have to do some borrowing. So you have 62 minus 34. Okay? 62, 34. Let's subtract. Okay? Same problem as before. In this column, 2 minus 4 is not going to work. You have a smaller number on the top. So we're going to have to borrow and make that a bigger number. Okay? What we're going to do is we're going to borrow from the next column over. We're going to scratch out that 6. It's now going to be a 5 because we borrowed from it. And we're going to put that thing that we borrowed right in front of the 2 here. And we're going to make it a 12. Okay? Now we have 12 on top and 4 on bottom. We can do that. So 12 minus 4 is going to give you 8. If you take 12 and subtract 4 from it, it's going to give you 11, 10, 9, 8. Subtract 4, we got 8. So you just put the 8 down. And then 5 minus 3, because the 6 is no longer in the problem. 5 minus 3 is just going to give you 2. And so the answer is going to be 28. Now let's do one more of these borrowing problems. 91 minus 76. We're going to write it down with the bigger number on the top. That's very important. And the smaller number on the bottom. And right away, working on this column, you should see that you've got a problem because you've got a smaller number on the top. 1 minus 6 isn't going to work. You've got to have a bigger number there. So we need to borrow. Okay? We're going to borrow from the next column. We're going to scratch out this 9, and we're going to put an 8 there because we're borrowing from it. And we're going to put a 1 in front of here because we're taking 1 away from here and we're adding it here. And so you have 11 now. 11 minus 6 in this column, 11 minus 6 is just going to give you 5. Okay? 11 minus 6 is going to give you 5 because you can go starting at 11, 10, 9, 8, 7, 6, 5. And then we're done with this column, and then over in this column, 8 minus 7 is just going to give us 1. So the answer is going to be 15. So basically, you do it exactly the same thing as addition, starting in the right-hand column, working left. So that's exactly what we did up here. We had in the right-hand column a smaller number on the top and a bigger number on the bottom, so we had to borrow. We borrowed from the 6 here, scratched it out, put a 5, so we took 1 away, we got a 5. We borrowed and made this a 12 by putting a 1 in front. Now we had 12 minus 4 and 5 minus 3, and we could do those two subtractions with no problem. And the same thing happened here. We had a 1 minus 6, which was, you can't do that because you got a smaller number on the top. So we borrowed. We took 1 away from here, made it an 8. We added it to here by putting a 1 in front, made this an 11. 11 minus 6 gave us 5. 8 minus 7 gave us 1. And so we just worked from the right, made our way to the left. And that is how you do subtraction of 1 and 2 digit numbers. Hi, and welcome to this section of the tutor where we're going to learn how to subtract 3 and 4 digit numbers. And the good news is the rules are exactly the same as what we learned in the last section on how to subtract 1 and 2 digit numbers. So let's go ahead and do a few problems here. If you have 317 minus 27. Now if you had a problem where you were subtracting 317, taking 317, subtracting 27, where you had a 3-digit number minus a 2-digit number, the first thing you would do would be proceed in the same way that we had started all the other problems. And that would be to go ahead and write the big number on the top, the 317, the 3-digit number on the top, and let's go ahead and write the 2-digit number on the bottom and go ahead and put our subtraction symbol. And that would really be the first thing that we do. Okay, that's sort of the first thing we're always going to do for these problems. And then, just like before, we're going to start in the right-hand column and we're going to do some subtraction. So there's really no difference here. The only difference is the numbers are a little bit bigger. But if you were going to start in this column, you would say 7 minus 7. And 7, take away 7, you should just remember is 0 because you're subtracting everything away, so there's nothing left. Okay? The next thing we need to do is look at the next column here, and here we have a 1 minus 2. But this is the same problem that we had before. We have a smaller number trying to subtract a larger number from it, so you can't do that. You can't take 1 and then subtract 2 from it. At least you don't know how to do that yet. So what we're going to do is borrow. We're going to borrow from the bank here. We're going to borrow from the 3, and we're going to make him a 2. So we're going to take 1 away from the 3. And the 1 that we take away, we're going to put it right here in front of this number that we're trying to make bigger. We're going to make him an 11. So that 1 that we put in front, we're just going to make him an 11. Okay? Now we can do this. 11 minus 2, starting with 11, 10, 9, subtracting 2 from it, we're going to be left with 9. Okay? So we're going to put a 9 right there. Okay? So 11 minus 2 is 9, and that's going to be that part there. And then the only thing left to do is we have this 2 here, subtracting 0 because there's nothing there, so we're going to have a 2. So the answer is going to be 290. Okay? So it's the same thing as before. We start on the right and we move left. Okay? Looking at a different problem, if we had 410 minus 34, okay? Let's go ahead and work that out and see what we would have. Let's write the bigger number on the top, 410, and we'll write the smaller number on the bottom. And we'll put a little minus sign because we're going to do some subtraction here, okay? Now again, the first thing we notice, if we're going to work in the right column moving left, we have a 0 minus a 4. Well, 0 is smaller, so we're not going to be able to do that subtraction right away. We're going to have to borrow. We're going to have to make this number bigger. So what we're going to do is we're going to borrow from this column. So we're going to strike him out, and since I don't have too much room, I'm just going to kind of put a 0 up here to remind me that that's a 0 now, okay? And I've borrowed 1, so I'm going to go ahead and put a 1 here, and that's going to tell me that this is a 10 in this column over here. So I've taken 1 away from this column and I've put it in this column. Okay, so now I have 10, 1, 0, 10, minus 4. And if you look at that and you do that on your fingers, 10 minus 4, starting with 10, 9, 8, 7, 6. I subtracted 4, so what I'm going to be left with is 6. And 6 goes right here, underneath that column. 10 minus 4 is 6. So we're done with that column after we've done the borrowing. Now let's move to this column. Now here, we don't have 1 anymore. That 1 is gone. What we have is 0 minus 3. Well, here we have the same problem as before. We have a smaller number trying to subtract a bigger number. So we have to borrow again. So what we're going to do is we're going to borrow from the 4 and we're going to make him a 3. Okay? And we're going to take that 1 that we borrowed and I'm going to put it right in front of that 0 right there. And that means that this is now a 10. 1, 0, 10. Okay, so we just did the same thing that we did before. We borrowed again, okay? 10 minus 3, starting at 10, 9, 8, 7. We subtracted 3 and we got 7. So the answer here in this column is just going to be 7. Okay, and we're done with that subtraction. Now let's move to this column. Well, there's no more 4. He's now a 3. So 3 minus 0 is just going to give you 3. 376. Now this is a really interesting problem, really cool problem, because you start out in this column, you have a 0. Initially, you have a 0. You can't subtract 4 from 0, okay? So you have to borrow. So we borrowed from the 1, we made him a 0, and we made this a 10 over in this column. 10 minus 4 gave us 6. But then when we tried to do this subtraction, we had the same problem. Because we had borrowed, we made this a 0. 0 minus 3, you can't do that either, so you have to borrow again. So again, we always borrow from the number to the left and make him 1 less. In this case, we made this a 3. And what we borrowed went up here and made this a 10. And 10 minus 3 gave us the 7. 3 minus 0 gave us the 3. So really, the rules are the same, okay? You may have to apply them a few times, but the rules are the same. You start on the right, you try to do some subtraction, and if you get into a point when you have to borrow, you go ahead and borrow, and you may have to borrow several times before the end of the problem, okay? If you have 289 minus 181, okay? First thing you would do would be to write the bigger number on the top, just like this, and the smaller number on the bottom. And we're going to do the subtraction, okay? You start in the right-hand column. 9 minus 1 will give you 8. 9 minus 1 gives you 8. 8 minus 8, you're taking away everything, so you have 0 left. You take 8, you throw 8 things away, you have 0 left, okay? And then in this column, 2 minus 1, this is going to give you 1. So here we didn't have to do any borrowing because every time we subtracted, we could just write a number down, a single digit. So the answer is 108. Okay? Getting to a little bit more challenging problems, 787 minus 692. How would we do that? Again, we want to write the big number on the top, okay? 787, that's on the top. And the smaller number, we're going to write it on the bottom, just like this. And we're going to subtract those two numbers. Same thing as before. Start in the right-hand column. 7 minus 2, what is that going to be? Starting with 7, subtracting 2. 6, 5. We subtracted 2. We have 5 left. So we have 5, okay? Now when we get to this one, 8 minus 9, you have the same problem as before. You can't do this because 8 is smaller than 9. You have to start with something bigger. So we're going to have to do some borrowing here. Okay, so we're going to have to do some borrowing here. So how would we do it if we want to do some borrowing? Well, we're going to borrow from the 7. We're going to scratch him out. We're going to make him a 6. We're going to take the 1 that we borrowed, and I'm going to put it right here in front of that 8. Okay, and it's going to be 18. Okay, so now when we go back, 18 minus 9 is going to give you 9. And to convince yourself of that, you can start at 18 and subtract 9. 17, 16, 15, 14, 13, 12, 11, 10, 9. And that gives you 9. And then 6 minus 6 is going to give you 0. And anytime you have a leading 0, you can just not even write it down. So the answer is 95. Okay? The answer is 95. So you see, I'm just working a lot of different problems, not really so much because they get really harder. They don't really get any harder. It's just because it's like riding a bike, like I was telling you before. You have to work through a lot of these things in order to be really good at them. And so that's what we're doing. We're just working through a lot of problems. So let's do some bigger numbers here. What if we had 2,347 minus 999. Well, the first thing you want to do is you want to write the bigger number on the top, 2,347 on top, and then 999 on the bottom. Okay? 999 on the bottom. We want to do the subtraction. So what do we do first? We start in the right-hand column, and we realize that 7 minus 9 is not going to work out because we've got a smaller number on top. We're trying to subtract a bigger number from it. So we're going to have to do some borrowing. So let's do that. We're going to scratch through this 4. We're going to borrow 1. So we're going to make him a 3. So we're going to write a 3 on the top there. Now the one that we borrowed goes in front of the 7, making him 17. Okay? So that's all we did. We borrowed from the 4 and we made a 17 here. Okay? So now 17 minus 9, let's go ahead and do that, starting at 17. 16, 15, 14, 13, 12, 11, 10, 9, 8. Okay? So we're going to have 8 left under here. We're going to have 8 left under here. 17 minus 9 is going to give us 8. That's all we did there. Okay? Now, let's go to the next column. Here, we have 3. There's no more 4 anymore. You have to deal with 3. But you see, 3 minus 9 is going to give us the same exact problem as before. We're not going to be able to do that because you have a smaller number on the top, so we're going to need to borrow. Okay? So where are we going to borrow from? We're going to borrow from here. We're going to scratch out that 3, and we're going to make him a 2, and the one that we borrowed from this guy is going to go in front of the 3, making him a 13. Okay? So now you have a bigger number on top. 13 minus 9 is going to give you 4. And I'll let you count that on your fingers, but 13 minus 9 is going to give you 4. Okay? Great, now we're done with this. Now we move on to this guy. Now again, we're going to have the same problem, 2 minus 9. We're going to have to borrow again because we've got a smaller number on the bottom. So let's go ahead and do that. Where are we going to borrow from? We're going to borrow from the digit to the left. We're going to take 1 away from him, making him a 1, and we're going to give that 1 right in front, making him a 12. Okay? So now we can do this. Because 12 minus 9, you can do that. You can do that on your fingers, and that's going to be 3. Okay? 12 minus 9 is 3. So we're done with that column. And then finally over here on the left, 1 minus 0 is just going to give you 1. So the answer is 1,348. This, truthfully, is probably one of the hardest problems you're ever going to have to do because you've got to do all this borrowing, okay? Really, if you just take your time and think through it slowly, and notice how I wrote the numbers kind of far apart so I had plenty of time to use my pencil and kind of write down what I was borrowing, then you can get the right answer and not get confused. We start in the right column, we had to borrow here. We took it away from the 4. We did this subtraction. But then when we came here, 3 minus 9, we had to borrow again. So we borrowed from the next guy. We made him a 13. But then when we came here, 2 minus 9, we realized we had to borrow again. So we borrowed from the 2, making him a 1 and making that a 12. Doing that subtraction, giving me a 3. And then finally, on the leading number, 1 minus 0 gave us the 1. That is probably one of the harder problems you're going to have to do. It's probably one of the harder problems you're going to have to do. Because you have to borrow 3 times in that case. And it becomes tricky sometimes, okay? So let's say you have 6,734 minus 5,843. How would you do that? Well, first, let's write it over here, bigger number on the top. 6,734, okay? And on the bottom, I'm going to have 5,843. And we're going to do some subtraction here. And notice how I wrote the numbers kind of far apart so I'd have time to do my borrowing, okay? If I have to borrow. So looking at the right-hand column, 4 minus 3, that's easy to do. 4 minus 3 gives me 1, okay? 4 minus 3 gives me 1. Let's go to this column, 3 minus 4. Well, here I have a problem because this number is smaller. I'm trying to take more away from the 3 than I actually have, so I have to go ahead and do some borrowing. So where am I going to borrow from? I'm going to borrow from the next digit over. I'm going to make him a 6, and the one that I take away, I'm going to put him right here in front of that 13, in front of that 3, making him a 13. Okay? Now I can do this. 13 minus 4, let's go ahead and do that, starting at 13, 12, 11, 10, 9. So I took 4 away, and I ended up with 9. Okay? So this is going to be a 9. Okay? Now let's work on this column. 6 minus 8. I have the same problem. I can't do that because this number is smaller and I've got to borrow. Where am I going to borrow from? I'm going to borrow from the digit to the left, making him a 5. Okay? The one that I took from here, I'm going to put it in front of that 6, making it a 16. Okay? So now 16 minus 8 is going to be 8. And the way you can figure that out, starting at 16, 15, 14, 13, 12, 11, 10, 9, 8. I took away 8, and that gave me 8 in the final answer. So 16 minus 8 gave me an 8. Now moving to this column, 5 minus 5 is just going to give me a 0, so I can put a 0 here. But any 0 in the front is just going to not even matter. You don't even have to write it down. So the answer is 891. Okay? Same thing as before. Start at the right, work your way, and borrow when you need to. And just make sure you do it slowly so you don't make a mistake. Okay? I'm going to do one more problem showing you how to subtract these 4-digit numbers. And then we'll wrap it up. 8,785 minus 2,197. So if I want to do this, I'm going to write the big number on the top, 8,785 minus 2,197. I'm just going to write it like this. And I wrote my numbers spaced apart so I can do some borrowing if I need to. Okay? First thing I'm going to do is start working in the right-hand column. 5 minus 7. Well, I've got a problem because the 5 is smaller. So I need to do some borrowing, right? So where am I going to get that from? Where am I going to borrow from? I'm going to borrow from just to the left. I'm going to scratch this 8 out. I'm going to make him a 7. Okay? And the one that I took away from here, I'm going to put it in front of the 5, making him a 15. Okay? That's exactly how you borrow. Now I can do 15 minus 7. I can do 15 minus 7 starting at 15, 14, 13, 12, 11, 10, 9, 8. Okay? So I'm going to have 8 right here. Okay? 15 minus 7 is going to give me an 8. Okay? Now let me work in this column, 7 minus 9. Now that's obviously a problem for the same reason. I got a smaller number on top than the bottom, so I've got to borrow so I can make this bigger. Okay? So where am I going to get the money from? I'm going to get it from the bank. I'm going to make this 7 a 6, and the one that I took away from that 7, I'm going to give it to this guy, making him a 17. Okay? So I'm going to give it to him, and I'm going to make him a 17. Now 17 minus 9 is going to give me 8, and the way you can figure that out is starting at 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. Took away 9, gave me 8. 17 minus 9 gives me 8. Okay? Now moving over to the left, 6 minus 1, you can do pretty easily is 5. Okay? Just taking 1 away makes him 5. And then 8 minus 2 is going to give me 6. Okay? So the answer is going to be 6,588. You start at the right. Anytime you have a smaller number on top, you borrow. You borrow from the guy on the left, give that 1 over here, made him a 7, did that subtraction. But then when I got here, 7 was smaller than 9, so I had to borrow again. I got the money from the bank over here, made him a 6, gave that 1 over here, made him a 17. Now I can do that subtraction. And then I can do 6 minus 1 and 8 minus 2. And that is basically how you subtract 3- and 4-digit numbers. But you can do this for no matter how many digits you have. You could have, 10 digits long minus 7 digits long. You just start at the right, work your way across the problem to the left, borrow whenever you need to borrow, and make sure and keep it straight, and you'll always get the right answer for these kinds of problems. Hi, and welcome to this section of the Elementary and Middle School Math Tutor. And in this section of the course, we're going to bring up the subject of multiplication, okay? A lot of students have trouble at first when the topic of multiplication is brought up because it just seems weird. It doesn't really make sense at first what they're trying to do, okay? Well, I'm going to explain it to you here, and hopefully you'll understand, and I think that you will, okay? The big picture is multiplication is a shortcut for addition, okay? That's what I really want you to remember. You can add up as many numbers as you want, and you can count and count and count, and it all works, okay? But when you're dealing with really big numbers, it can be tough to write them all down and to add them all up, okay? It just takes a long time. So they invented this thing called multiplication I'm going to talk to you about a little bit. And basically, you're going to have to remember some things. You're going to have to remember your multiplication tables, okay? But I'm going to show you how to do that. I'm going to show you how to build upon that to multiply any two numbers of any size, okay? Now, this section of the class is not going to have too many problems in it. It's going to be more of a description of what multiplication is, but as far as like what exactly does it mean, and then as you get into the sections that follow this section here, you'll get into some more of the problems, okay? So the first thing that I want to kind of write on the board is the following, okay? Multiplication, okay, is a shortcut for addition. That's exactly what I told you a minute ago. It's a shortcut for addition, okay? And what do I mean by that, okay? Let's say you have, let's use a different color. I'm in the mood for blue right now, so let's do that, okay? Let's say you had two balls, okay? You had two balls, and I'm going to add to it two more balls, okay? And I'm going to add to it two more balls, okay? So you already know how to add this stuff up, okay? You already know how to add this stuff up because what you have here is you have two balls here, okay? And you have two balls here, and you have two balls here. So if I were just going to ask you, how would you add these together? What would be the answer? Well, then you would say, well, that's simple. That's just 6, right? Because you just count 1, 2, 3, 4, 5, 6. And you can do that, no problem. And you got the answer. Write it on your test, you're done, right? Well, that's true, okay? But let me show you what multiplication is, and let me show you why it's the same thing as what we've done here. Here we have some addition. We got the answer of 6. So remember that, okay? Now, what I've done is I have a group of 2 here, okay? And I have 3 groups of 2, okay? The way I've drawn it on the board is I've got, in each group, okay, I've got 2 things, right? But I've got 3 groups of 2. 1 group, 2 groups, 3 groups. So I've got 3 groups total, and in each group I have 2 things, okay? So the way that you write this down in multiplication, okay, is you say, okay, 3 times 2. Okay, that's what you say. You put a big X here, and that just means 3 times 2, okay? What it's telling you is you have, and the first number is how many groups you have, in this case 3 groups. The second number is how many numbers in each group, how many things in each group. These could be pencils or pens or apples or whatever, but I have them grouped like this. So 3 times 2, and you already know that the answer is 6, okay? You already know that the answer is 6 because we already told you that, you already counted that this is, when you add up all the stuff, you get 6. So you see that multiplication is the same thing as addition. And congratulations, by the way, you've just learned your first multiplication. 3 times 2 is 6, okay? Now, anytime you see multiplication like this, you can draw it out and you can add it up and you can figure out the answer. But it turns out that any 2 numbers can be multiplied together. You could have 5 times 7. You could have 6 times 5. You could have 7 times 10. And there's just so many different ways you can do it, okay? And you could draw it out for each and every time, okay? But what you're going to end up having to do is memorize them. You're going to have to just remember them. And after a while, you will remember, I promise you, that 3 times 2 is 6. You'll just remember that, okay? So what I'm going to do to drill this in a little bit, what this means is this is 3 groups of 2 things, okay? 3 groups of 2 things, and that's why it's 3 times 2, okay? Now let me show you one more thing under here. I'm going to leave all this on the board. Let me show you one more thing. Now let me do things a little bit different, and let me draw it like this. What if I have 1 circle, 2 circle, 3 circle, and I'm going to add to it 3 more circles, okay? Now, it's the same number of circles in both cases, okay? But what I have here is I have 3 circles, okay? And I have 2 groups, okay? So what this would be, okay, instead of 3 times 2, this is going to be 2 times 3, okay? 2 times 3. 2 groups, 3 things in each group. And you already know that the answer is going to be 6. because you can just look at the board and count 1, 2, 3, 4, 5, 6. Okay? So what I'm trying to point out to you here, okay, by drawing on the board and showing you two different examples, this is 3 groups of 2 things in each group, and this is 2 groups with 3 things in each group. Okay? Here you have 3 times 2 is 6. Here you have 2 times 3 is 6. And that's going to be true in any multiplication problem. 3 times 2 is 6. Okay, 2 times 3 is 6. You can flip the order around and it doesn't matter. You're going to get the same answer, and that's kind of cool, right? I mean, you only have to remember one of them and you automatically know what the other one is, okay? 3 times 2 is 6, 2 times 3 is 6. So if you remember, as you study your multiplication tables, okay, that 5 times 4 is 20, okay, then you automatically know, since 5 times 4 is 20, that 4 times 5 is also 20. The backwards one is true, okay? If you happen to know that 2 times 4 is 8, okay, because you know that from multiplication tables, let's say 2 times 4 is 8, then you automatically know that 4 times 2 is also 8. Because anytime you have multiplication, you can flip the order around, okay, and you're going to get the same answer, okay? It's just the way it works, which means it's really easy because if you know one of these things, if you flip it around, you automatically know what the other one is. Okay, so what we're going to do next is I'm going to show you another example of this, okay? I'm going to show you another example of what multiplication really is. And you can see that what we have done here is all we've done is we've created a shortcut for addition. That's all it is. And you basically just have to remember them, okay? What if we have 1, 2, 3, 4, 5 balls, okay? And I have 1, 2, 3, 4, 5, another 5 balls, okay? Well, right here I know I have 5 balls, okay? And here I know I have 2 groups, okay? Okay, and you know that if you're going to add these together, you're going to get 10. Because you have 5 here and you have 5 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. You can add them up, no problem. But what this is telling you, what multiplication really is, okay, is it's telling you that when you group it like this, 5 times 2, okay, is 10. And it's also telling you that 2 times 5 is 10. Just like we said before, anytime you have multiplication, you can flip them around and you get the same answer. So this is how they create those multiplication tables that I know that you've seen. Okay, this is how they create them. They go and they take the first number and the second number and they group them up and they add it together, and that's how you get the number. So 6 times 4 is 24, for instance, okay? You know, 5 times 6 is 30, things like that, okay? They do it by taking and drawing things out and counting. Now, it's a real pain to add those things up all the time. So what you're going to have to do is just remember them and study your multiplication tables, and you'll remember them, and then you'll know how to multiply. Okay? Let's do a couple more so you get the hang of this. So you see, just to understand what multiplication is, okay? What if you had a problem like 1 times 6, okay? Well, what does that mean? Okay, that means one group with 6 things in each group. So what I'm going to have is 1, 2, 3, 4, 5, 6. Okay, I have one group, and in that one group, I have 6 things in that group. So 1 times 6 is 6. Okay, 1, 2, 3, 4, 5, 6. 1 times 6 is 6, and you'll just get the hang of that from your multiplication tables. Anything times 1 is itself. So 1 times 7 is 7, okay? 1 times 8 is 8, okay? 1 times 374 is 374. Anything times 1 is just itself. 1 times 2 is equal to 2, okay? And that's just because you have one group with 2 things in that group. So when you add them up, you just get 2. So I'm teaching you here, based on what multiplication is, that anything multiplied by 1 is just going to be itself. Okay, and that's something really useful because, you know, now you've already learned your first multiplication table, the ones multiplication table. 1 times 1 is 1, 1 times 2 is 2, 1 times 59 is 59. It just goes like that. So anything times 1 just becomes itself, okay? That makes things really, really cool and really go nicely and help you remember things. Okay? Next thing I want to talk to you about is when you multiply something times 0. 0 times 7. What does this mean? This means you have 0 groups of 7. Now think about this for a second. What I'm saying is, in each group, I have 7 things, okay? But I'm multiplying by 0, so that means I don't have any groups, okay? Anything times 0 is 0, because I have 7 things in a group, but this is telling me I have no groups, none, zilcho, nothing in front of me, okay? So anything times 0 is 0, because this 0 cuts it down. Anything times 0 is 0, okay? So 0 times 1 is 0. 0 times 7, well, we've already said that. 0 times 8 is 0. 0 times 54 is 0. Anything times 0 is 0, and that's exactly why, because you have this many units in a group, but you don't have any groups. And so when you add those up, you don't get anything, okay? So that's about all I really want to cover in this section. Just remember that multiplication is a shortcut for addition. That's all it is. It's not that hard. And what you have is 2 numbers involved in every multiplication problem. The first number times the second. One of those numbers tells you how many groups of something you have, and the other number tells you how many things you have in each group, okay? And so you could just write all those out and count them up, but what you're going to end up having to do is memorize these multiplication tables, okay, which, you know, can be a challenge, but we're going to help you through that, and you can go from there and you can start to work more challenging multiplication problems once you know your multiplication tables. Welcome to this section of the tutor where you're going to work some multiplication problems and you're going to get some practice solving multiplication problems. Before we get into the actual solving of the problems, I want to make very, very sure that you understand that it is very important to go and learn your multiplication tables. I know they're not that fun, I know they're not the most exciting thing in the world, but you have to learn them, because if you don't, you're just going to get behind in this stuff and it's not going to make sense, and you're going to be left kind of wondering exactly what's going on. So if you don't know your multiplication tables, or if you don't know them that well, take a minute to go look at your multiplication tables, take a look at them, practice them. Every day you should go through your multiplication tables until you remember them. You can also play the section of the DVD that you have here that'll kind of go through your times tables, and do that over and over again, and believe it or not, after a while you'll just remember them because you're going to use them a lot, okay? So let's go ahead and work some multiplication problems. We're going to start out with some easier ones, and then we're going to move up from there. So what if you have 5 times 3, okay? They're going to give you the problem like this, written like this, 5 times 3. What I want you to do for each and every problem, just like we did for the addition and subtraction problems, I want you to write one number on the top and the other number on the bottom with an X. I want you to write them on top of each other. Now, 5 times 3 is pretty easy because it's basically just something you should know from your multiplication tables. Look at your multiplication table and figure out basically what is the answer, okay? And you should be able to remember, eventually remember, the multiplication of any 2 single-digit numbers. So you should know 5 times 3, you should know 7 times 6, you should know 9 times 9, but nobody's going to expect you to know what 29 times 34 is. Nobody's going to expect you to know what, 14 times 19 is off the top of your head. But you should be able to multiply any 2 single-digit numbers, okay? So these are single-digit numbers, so you should remember, or at least be able to look it up in the table, what the answer is. 5 times 3 is 15, so you just write 15 down, just like this, okay? You just write 15 down just like this, okay? Now, the next thing would be 7 times 2. That's the next problem, okay? Again, it's a 2 single-digit number, so I'm just going to write the problem like this. And you should remember from your times tables, or look it up if you don't remember, or go review the section of the DVD. 7 times 2 is 14. So you're going to write that down. Now notice in each of these problems, I'm not doing a lot to explain what's going on here, and that's because multiplication really and truly is a matter of remembering. You're just going to have to go over it over and over again and remember. And once you do that, then these will come very easily. What I'm going to lead up to here is teaching you how to multiply numbers that get bigger and bigger and bigger. where you don't remember the answer, okay? But these, I'm just kind of leading you into it. These are some problems that you should eventually just remember, okay? These single-digit problems here, okay? Again, 6 times 4, okay? You should know what that is. We're going to write it on top of each other with the multiplication symbol. 6 times 4, you should remember from your times tables, is 24. I'm just going to write that down. 6 times 4 is 24. Okay? What about 3 times 3? Okay? I'm going to write that down just like this. And you should remember from your times tables that 3 times 3 is just going to give you 9. Okay? 3 times 3 is 9. So here we have done single-digit problems. And these are digits, these are problems that really you should know from your times tables, or at least that you could look up if you don't remember the answer in your times tables, okay? Now let's move into some more challenging problems. 11 times 4, okay? Some people, many people, memorize the 11 and 12 times tables, okay? And that's fine, you can do that. You can just remember that 11 times 4 is going to give you 44. I know that because I just remember it from when I was little, okay? But I'm going to teach you how to do this without having to remember it, okay? What you're going to do is you're going to write the bigger number on the top, just like we always do, and the smaller number on the bottom, okay? Now here is how you multiply, okay? Again, you start in the right-hand column, okay? You start in the right-hand column. 1 times 4 gives you 4. So you put that down. Remember, anything times 1 is itself. So we're done with this. Now what you have to do with multiplication is you have to kind of put a pivot here. You're going to have to multiply by each number. So the 4 is going to have to get multiplied by the 1, giving you this, and then it's also going to have to be multiplied by this 1. It's going to give you another number. So 4 times this 1 gives you 4. You're going to write that one in front, giving you a 44. So it's a little bit different than addition and subtraction. In addition and subtraction, we just dealt with what's directly above in each column. With multiplication, things are a little bit different because this 4 has to be multiplied by each digit above. Okay, so what we're going to do is we're going to work left and we're going to keep multiplying. 4 times 1 gave me 4. 4 times this 1 gave me this 4. So the answer was 44. And that's why we're going to do a lot of problems in this section to make it really clear. 13 times 2. Well, first we're going to write the 13 on top because it's bigger, and we're going to write the 2 on the bottom, and we're going to push the 2 over to the right, okay? And we're going to start in the right-hand column. 2 times 3 gives you 6. You should remember that from your times table, so we write it down, and we're done. But now we need to multiply 2 times 1 because we need to multiply by this 1 here. 2 times 1 gives us 2, so the answer is 26. So basically, every digit you have, you've got to multiply by each digit like this and keep adding the numbers down here. So you get 26. So you see, 13 times 2 is probably nothing that you would ever memorize in a multiplication table. You probably don't remember what that is. But using some very simple multiplication that you do remember, you can get the answer. So we're going to build on that. We're going to get bigger and bigger and bigger and bigger, and we're going to work more complicated problems, and you're going to get the hang of how to do this really, really easily. Okay, so what if you had 12 times 8? Okay, first thing I'm going to do is I'm going to put the 12 on the top and the 8 on the bottom. Okay, just like we always do. And I'm going to work with the right-hand column first. 8 times 2, you should remember from your times tables, is 16. Okay, now here's where we get into something a little bit more complicated. Because it's 2 digits, okay, because it's 2 digits, you can't just write the whole thing down here. 8 times 2 gives you 16, but just like in the addition problems, you put the 6 up there, or down there I should say, okay, and you got to put the 1 somewhere, but I don't want you to put it down here. I want you to put the 1 up here, up above, okay? So 8 times 2 gave me 16, but it's 2 digits, so I don't want to write them down there. I write the rightmost digit here and put the 1 up there, okay? Now, pay very close attention to what we're doing here. We're going to do the same thing that we did before. 8 times 1 gives me 8, okay? But there's a 1 here, so what do I do? What you do is you say 8 times 1 gives me 8, plus this 1 gives me 9. So I'll put a 9 down here. 8 times 12 is 96, okay? That is how you do it. Anytime you have a number here, 8 times 2, it's going to give you 16. You put the 6 here, let's say, you put the 1 up here, and then when you get around to multiplying this guy right here, you do the multiplication. 8 times 1 is 8, but then you add this number here. Plus 1 gives me 9. Okay? So it's a little bit different than the addition problems. You have to be real careful to make sure that you're doing the right thing here. And we're going to work a ton of problems to make sure that you understand how to do that. Okay, so if you don't get it quite in the beginning, don't worry about it. Keep watching, okay? What if we had 22 times 9? What do we do next? Let's write the 22 on the top, okay, the bigger number. Let's write the 9 on the bottom, like this, okay? Let's go ahead and work in this column. 9 times 2 gives me 18 from your multiplication tables. 9 times 2 gives me 18. But 18 is too big to write here. It's 2 digits. So I'm going to put the 8 here, and I've got to put that 1 somewhere. So I'm going to put that 1 up here on top of the column to the left. Okay? So 9 times 2 gives me 18. Okay? Okay, let's move on. Let's take 9 times this 2, because remember, you have to keep multiplying over like this. 9 times 2, what does that give you? It gives you 18. But then you have to add this one, which gives you 19. So you put 19 down, like this, okay? So basically, you do everything the same as before, multiplying like you do, but anytime you have to write one of these numbers up there, you just make sure and add that to it after you do the multiplication. So 9 times 2 gave us 18, put a 1 up there, and then 9 times this 2 gave us another 18, but we had to add 1, giving us 19. So we had 198. Okay? What if you had 36 times 4? Okay? We're going to write 36 on the top because it's the bigger number, and we're going to write 4 on the bottom. And we're going to do multiplication here. Okay? So the first thing we're going to do is we're going to work on the right-hand side. 6 times 4, you should remember from your times tables, is 24. But 24 is too many digits, so you don't want to write that down. So you put the 4 down, and you have to put the 2 somewhere because you're trying to write 24. 6 times 4 is 24, but you put the 2 right above the next column. So you had to write 6 times 4 is 24. We wrote it down just like this, okay? Now let's move on. Let's multiply. 4 times 3 gives you, from your times tables, 12. 4 times 3 gives you 12, but you have to add 2 more. So 12 plus 2 gives you 14. So because 12, 13, 14. So that gives you 14. So you put 14 down, 144. That's the answer. So again, 6 times 4 gives 24. Put the 4 down, put the 2 up here, just like before. Now 3 times 4 is 12, plus 2 gives us the 14. And basically, once you know this rule, all of the problems are done exactly the same. There's no more tricks in multiplication. If you know your times tables, and you know these tricks that they're not really tricks, if you know the rules, then you're going to be able to multiply any two numbers together as long as you just take your time with it, okay? Okay, now let's go for something a little bit more challenging. Let's say you have 51 times 21, okay? So let's go ahead and write the bigger number on the top, 51, and we'll write 21 on the bottom, like this, okay? Now, the only difference between this problem and the last is that this number on the bottom is 2 digits long, okay? So what you're going to do is you're going to start by multiplying these numbers here, just like before, and then after that, you're going to multiply these numbers, okay? So let's go ahead and do that. 1 times 1 gives me 1, okay? 1 times 5 gives me 5. So I just write that down, okay? Now, the only thing you really have to remember, okay, is that before you start multiplying these guys, when you move down to the next line, you have to put a 0 here. So put a 0 down. We'll explain why later, okay? But just go ahead and do that. Now 2 times 1 gives you 2. I'll put that one there. And then 2 times 5 gives you 10. And I'll put that down there, okay? So you draw a line, and now you have two numbers, 51 and 1020. Now you just add these up. So now you have two numbers, one on top of each other, and all you have to do now is add them up. 1 plus 0 gives you 1. 5 plus 2 gives you 7. 0 plus 0 gives you 0. 1 plus 0 gives you 1. So it's 1071 is the answer. So this is an example of two numbers multiplied together that you would never remember just by multiplication table. You would never know. But using the rules, you can multiply any two numbers together. When you have more than one digit on the bottom, you start at the right. 1 times 1 gives you 1. 1 times 5 gives you 5. Okay, you're done with this digit. Now you move to here. But before you start multiplying, you have to put a 0 down. Put a 0 in this column. 2 times 1 gives you 2. 2 times 5 gives you 10. And then you add these up. Okay? And the reason you have to add the 0 here, by the way, is because this 2 is off to the left. It's worth more than this 1 is. And so anytime you have more digits here, you're going to have to add more zeros before you add them all up. We're going to do some more problems and you'll see exactly how to do that. But this 0 is very important. If you didn't put the 0 here, you get the complete wrong answer. And then whenever you get the two numbers here that you have done the individual multiplications on, you just add them up and you get the final answer. Okay? Let's do that again because that can seem a little bit complicated, but let's do that again and we'll get the hang of it here. Okay. 19 times 13. Okay? How would we do that? 19 on the top, 13 on the bottom, like this, okay? We start in the right-hand column. 3 times 9 is 27. So we can't obviously write 27 down here, so I'm going to put the 7, okay? And then I'm going to put the 2 somewhere. The 2 has to go here, okay? Has to go on top of the other column, okay? Now, 3 times 1 gives me 3, plus 2 more gives me 5, okay? So this is going to be a 5, okay? So basically I've taken this 3 and I've multiplied by both of the numbers on the top, so I'm basically done with that, okay? Now I'll put a 0 here, because anytime I start multiplying by the next number over, I've got to put a 0, okay? 1 times 9 gives me 9, and 1 times 1 gives me a 1. Now this 2 here has nothing to do with this multiplication, okay? Because remember, we only put this 2 because of the 9 times 3 gave us the 27. So you basically totally ignore it and just forget about it when you're working with the other multiplication over here. So 1 times 1 gives us 1, okay? Now, the next thing you do after that is you draw your line, you have to add these two numbers together. 7 plus 0 gives you 7. 5 plus 9 gives you 14. You just remember that from your addition. So because it's 14, we have to put a 4 down here, carry the 1 over, okay? And then 1 plus 1 gives you 2. If this addition is causing some confusion for you, then go back to the previous section of the video that talks about adding and subtracting, numbers, and then you'll see how to do that. But this is basically what you do here. So the answer is 247, but the rules are the same. 9 times 3 gave us 27, okay? And then we had to go ahead and put a 2 up here because we have the 2 and the 7. 3 times 1 gave us 3, add the 2 gives you a 5, okay? Then we put a 0, we started multiplying this. 9 times 1 gave us 9, 1 times 1 gave us 1. This 2 has nothing to do with this multiplication of the 1, so we don't even touch that. The 1 goes here, and then we just add these up and we get 247. Okay. I think we're getting the hang of things. Let's go ahead and do another few two-digit problems. Okay. What we're going to have is, let's try 27 times 37. Okay. 27 times 37. So you would have 27 on the top, 37 on the bottom. Okay. We're going to go ahead and do this multiplication. Okay. 7 times 7 from the previous section of the video on using your multiplication tables is going to give you 49. So I'm going to have 9, and I'm going to go ahead and write the 4 up here above the other column. Okay? 7 times 7 gives you 49, so I had to put the 4 up there. Now I'm going to multiply this times this. 7 times 2 is 14, plus 4 more gives me 18. 14 plus 4 gives me 18, so I write the 18 down. Now I'm going to move to this digit. When I do that, I'm going to have to put a 0 here. 3 times 7, I'm going to erase this now, this 4, because it isn't going to affect this multiplication of the 3. 3 times 7 is 21. 21 is 2 digits, so I can't write that down. So I'm going to put a 1 here, and I'm going to put the 2 up here, because I'm trying to write 21 down. Okay? Now, 3 times 2 gives you 6, plus 2 more gives you 8. So you put the 8 down. Now you have these two numbers, you got to add them up. 9 plus 0 gives you 9. 8 plus 1 gives you 9. And 1 plus 8 gives you 9. So the answer is 999. And you do it exactly the same as you've done the other problems. Start with the right, multiply like this, write down what you're going to do, and then whenever you have to carry, you do 7 times 2, for instance, was 14, and so on. And then notice that we erased the initial thing because what it was before was 7 times 7 gave us 49. Initially there was a 4 up here, and then 7 times 2 is 14, plus the 4 gave us the 18. Don't forget that whenever you go on and do the next digit in the multiplication, that this 4 that you wrote has absolutely no meaning whenever you do this next multiplication, okay? It's only because of that first multiplication, so that's when we use it. Okay. Let's go on and do 62 times 80, okay? 62 times 80. 62 times 80, okay? Now, what we're going to do here is we're going to start in the right-hand column, just like before. 0 times 2 gives you 0, okay? 0 times 6 gives you 0. That's pretty easy. Everything gives you 0. Now we're going to move on and multiply using the 8. And because we're doing that, we're going to have to put a 0 here before we can get started. 8 times 2 is 16. 16 is too big to write here, so you have to put one digit here, the 6, and I'm going to carry the 1 up here, okay? 8 times 2 gave me 16, had to put the 1 up here. Now, 8 times 6 from your multiplication tables is 48. But 48, don't forget you have to add the 1, gives you 49. So you have to put 49 down there. Draw your line, okay? Now you have two numbers, you add them together. Well, 0 plus 0 gives you 0. 6 plus 0 gives you 6. And you're just going to have to copy this 49 down because you're just adding 0 to it. So 4,690. So you see, once you get the hang of it, the rules are not terribly difficult. Not terribly difficult. What if you had 123 times 13? Okay, how would you do that? 123 times 13. Okay, same thing. You start at the right and go from there. 3 times 3 gives you 9. Okay, 3 times 2 gives you 6. 3 times 1 gives you 3. So you multiplied each digit by what we had on the bottom. Now we're going to move on to this digit, and because we're going to do that, we have to put a 0 there. Okay, 1 times 3 gives me 3. 1 times 2 gives us 2. 1 times 1 gives us 1. Easy enough. Now we just add these two giant numbers together. 9 plus 0 give us 9. 6 plus 3 give us 9. 3 plus 2 give us 5. And 1 plus 0 give you 1. 1,599. If these problems are, if you need a little bit more time to let it soak in, just rewind and watch it again. You start in the right column, 3 times 3 is 9, and you just work your way over writing it down, and you move to the next digit. But because you do that, you have to put a 0 here, and then you do all of these, writing all that down, and then you just add the two things together. Okay? So you can see that by using this method and doing it like this, you'll be able to multiply any two numbers together. So let's do that now. 504 times 21. Okay? So we write the bigger number on the top and the smaller number on the bottom. Okay? So we're going to start in the right-hand column. 1 times 4 gives you 4. 1 times 0 gives you 0. Remember, anything times 0 gives you 0. 1 times 5 gives you 5. Okay? Now, we're going to move over to this digit. So we're going to put a 0 here. 2 times 4 gives you 8. 2 times 0 gives you 0. 2 times 5 gives you 10. And when you get to the end here, you have no choice but to write the number down. So you draw a line and you add these two things up. 4 plus 0 gives you 4. 8 plus 0 gives you 8. 5 plus 0 gives you 5. Just take your 0 down here. 0 plus 0 gives you 0, and 1 plus 0 is going to give you 1. So the answer here is 10,584. It's a very big number, okay? 4 times 21. But when you think about it, what you have here is 504 groups of something, and each group has 21 things in it. So when you add all that together, it's going to come out to a big number. It's going to come out to this here. But again, the method is the same. Start from this digit, multiply like this, write your numbers down, put a 0 when you move to the next digit, and do this multiplication, and then you just add them up. And if you have to do any carryover, you just make sure and do that too. Okay. Now we're going to move into a little bit more challenging problem, but really it's the same. 267 times 136. So we're going to write 267 on top, 136 on the bottom, and we're going to do this multiplication. Okay, now given a problem like this, we want to go ahead and start like we always do, and we want to start in the right-hand column and begin to multiply all these numbers by this digit here. So this times this times this, and this times this, and we'll just go from there. So let's start from there. What's 7 times 6? You'll go back and look at your times tables, and that's going to be 42. But 42 is too big to write down here because it's 2 digits. So we'll put the 2 right there, and what we'll go ahead and do is we'll just put the 4 up above in the column to the left. So we'll write 42. We just write it like this instead of writing it down there like that. Okay, now we move on and multiply the next guy. Okay, now we move on to the next thing. 6 times 6 is 36, okay, but we have to add this 4 to it. Remember what we do is we go 6 times 6 is 36 and add whatever's on the top here. So 36 plus 4 is 40, okay, and you can do that on your fingers. 36 plus 4 is 40. So what we'll do is put the 0 down here, okay, and we can't put the 4 down here for 40. We have to put the 4 up here, over in the next column, because if you're going to write 2 digits like that, you need to write it over in the next column. So 6 times 6 gave us 36, plus 4 gave us 40, and then we just write it in the next column like this, 4 and then 0. Okay, now we continue multiplying. 6 times 2, and this digit gives us 12. 6 times 2 is 12, but then we have to add this 4. Okay, so 12 plus 4 is going to give us 16, right? If you do that on your fingers, 12 plus 4 is going to give us 16. And so what we're going to do here is we're going to write 16, okay? 16. Now I can write the 2 digits down here because there's nothing else left in the problem here. So basically you can write the 2 digits down when there's no other digits up here. So I'm going to go ahead and write the 16 down, okay? So we're basically done. You know, 6 times 7 gave us 42. Put the 4 up there and the 2 down there. 6 times 6 gave us 36, add the 4, and just keep on going on to the left. And we're done with this digit here. Now we have to go and multiply everything times this digit. So we'll go ahead and we'll add our 0 in, like we've always been doing when we start working with the next digit over. And we'll start to multiply all the digits by the 3. Okay? So 3 times 7 gives us 21. But 21 is too many digits to write down here. So I'm going to put the 1 down, and I'm going to put the 2 up here. Okay? Now, I'm putting it in a different color just to kind of keep it straight, because this 4 and this 4 here, they were only you only use those because you were multiplying by the 6. Now you basically ignore these guys and don't even use those at all when you continue on in the problem. So let's continue. 6 times 3 is going to give us 18, right? 18, but we have to add the 2. Remember, this 4 has nothing to do with it. That was left over from before. So 6 times 3 gives us 18 plus 2. 18 plus 2, 19, 20. It gives us 20, okay? So we're going to write 20 down. So we're going to put the 0 here, the 0 in 20, and we're going to have to put that 2 somewhere. So let's go ahead and put that 2 up there, okay? Like that, in the next column. So we're done with that one. So now let's move on. 3 times 2 gives us 6, right? But we have to add 2 because remember this 2 is here. This 4 is no longer involved. It was left over from before. So 3 times 2 gives us 6, plus 2 gives us 8. So we have an 8 there, okay? So we have an 8 there. Okay, now we're done multiplying everything by 3. So we're going to have to move over and deal with this digit, the 1 digit. Before we can do that, we have to put not 1 0, but 2 zeros. Okay, because we're dealing with this digit here, we have to add 2 more zeros, and now we can start multiplying. So 1 times 7, this is pretty easy, gives us 7. 1 times 6 is pretty easy, gives us 6. 1 times 2 is pretty easy, and gives us 2. And you guys should all remember anything times 1 gives you itself. Okay? And now that we have all these numbers here, to get the final answer, we just add them up. Okay? 2 plus 0 plus 0, I think you all know, is just going to give you a 2, because anything plus 0 is itself. 0 plus 1 plus 0 is going to be easy. It's going to give you a 1. 6 plus 0 plus 7. Basically what you have to do here is add 6 plus 7, so you can start with 7, 8, 9, 10, 11, 12, 13. So that's going to give you 13. And in order to remember how you add these things, it's 2 digits, so you can't write it all down here. So you write the 3, and what you're going to end up doing is you're going to end up writing a 1 kind of up here, like this, when you're adding these things together here, okay? And so when you add this column here, you need to remember to add that 1 in, okay? So 8 plus 1 gives you 9, plus 1 more gives you 10, and then 10 plus 6 is simply 16, okay? And let's do that again. 8 plus 9 is 8 plus 1 is 9, and then plus 1 more gives you 10, and then 10 plus 6, you can do that on your fingers, gives you 16. So in order to do that, we're going to put the 6 down in 16, and we're going to add, in another color to help you out here, we're going to add another 1 here to kind of show you, this is the 1 coming from the 16. And then you just go 1 plus 2 gives you 3. Okay, so the answer is 36,312. And that would be the answer when you multiply 267 times 136. So you see it's pretty methodical. You start in the right-hand column and you start multiplying like this. And anytime you get a 2-digit number, when you have a digit left here in the top, you just write the right-hand digit and carry the other one down up at the top. And then when you do a multiplication with the number on top here, you multiply, but then you add the number on top like we did here. Okay? And then when you move to the next digit, you have to add a 0 before doing all the multiplication. And then when you move to the next digit, you have to add 2 zeros before doing the multiplication. And when you finally do all that, then you add everything up using the rules of addition that we already learned previously, okay, to arrive at the answer. Okay? So we're getting here into the problems that are really the trickiest, kind of the hardest problems in multiplication, really, because you have a lot of digits. The longer the problem is, the more digits you're going to have, and the harder it's really going to be. Okay, and I really hesitate to say it's not really any harder. It's more work. Okay, so it's really the same thing you're doing. We're going to do one last problem here in multiplication, just to make sure that we've got it all practiced, and that's going to be 310 times 455, okay? How would we do that? First, we're going to write it on one on top of each other, okay? 310 times 455, and we're multiplying, okay? So again, we're going to start in the right-hand column, and we're going to kind of multiply like this, okay? So 5 times 0, using your times tables, is going to give you 0, because anything times 0 gives you 0, okay? 5 times 1 is going to give you, anything times 1 gives you itself, so that's going to be 5. 5 times 1 is going to give you 5. And then 5 times 3, when you think back to your multiplication tables, is just going to give you 15. So if you don't remember that, just look that in your tables. And there's no more digits up here, so I can go ahead and write the entire 15 down, okay? Like this, okay? Now we're done with multiplying everything by this 5, okay? We want to move on and multiply everything by this number, the next digit in there. But before we can do that, we have to add our nice friendly 0 down. 1 0 because we're moving one digit to the left, okay? Now 5 times 0, again, is going to give you 0. 5 times 1, again, is going to give you 5. And 5 times 3, again, is going to give you 15. And notice I'm lining the digits up, so everything's lined up perfectly, okay? Now we want to move to the 4, which is 2 digits, so I have to add 2 zeros. Okay? Now I can multiply by 4. 4 times 0 is going to give me 0. 4 times 1 is going to give me 4. And 4 times 3 is going to give me 12. Okay? 4 times 3 is going to give me 12. So I write that down. And now that I have all of this stuff written down, I need to add them up. So 0 plus 0 plus 0 is simply going to give you 0. 5 plus 0 is just going to give you 5. 5 plus 5 plus 0 is just going to do the same thing as 5 plus 5, which is going to give you 10. And just from your rules of addition, you know that when you add a number up and you have some numbers off to the left like this, and you get a two-digit number, you can't write the two digits down. So in order to write the 10, I'm going to put a 0 there, okay? And I'm going to kind of put another, kind of like a little 1 up there to kind of remind me I'm carrying a 1 here, okay? Now I've got to add this column, okay? 1 plus 1 is 2, plus 5 is going to give me 7, and then 7 plus 4 is going to give me 11. And you can kind of do that on your fingers, but you've got 5 plus 2 more gives you 7. 7 plus 4, starting at 7, gives you 8, 9, 10, 11. So that gives you 11. Again, same thing. I've got 2 digits, so I'm going to have to put the 1 digit down like this, and I'm going to carry another 1 up here into the next column. Okay? Now I'm going to add this column. 1 plus 1 gives you 2. And then plus another 2. 2 plus 2, as you know, is going to give you 4. So I'm going to put a simple 4 down here. Move into the last column. You've got nothing above it, so it's kind of like a 0. And you just put the 1 down. 1 plus 0 is going to give you 1. So the answer is going to be 141,050. Okay? So the only thing that you really need to be aware of when you're doing these multiplication problems, you now have the tools to be able to multiply any two numbers of any size. Okay? You can multiply a 10-digit number by a 17-digit number, but the rule is going to be the same. You start in the right-hand column and take that last digit and multiply by everything in the top, okay? When you're done doing that multiplication, you move to the next digit. But when you do that multiplication, you need to add a single 0 and then go ahead and do your multiplication again, right to left, okay? And then when you move to the next digit, you add 2 zeros and then do your multiplication right to left. If you had if you had a whole bunch of other digits out here, every digit you would go to the left to multiply, you'd have to add that many zeros in the bottom. When you finally have all of the numbers written down here, then you just simply add them up, okay? You simply add them up. And that is how you add, that is how you multiply numbers of any length. And what you need to do at this point is just practice, practice, practice. And I promise you it'll be second nature and you'll get really, really good at it. Hi, and welcome to this section of the tutor where we're going to tackle a subject that a lot of people have problems with, but I promise you I'm going to teach it to you and it's going to be easy, and that topic is the topic of division. Specifically, this is what I'm going to call division part 1, where I'm going to kind of introduce division and work some problems, and then later on in another section we're going to get into some more challenging problems. Okay, but right now what you need to remember is that division is not hard, and basically division is going to be the opposite of multiplication. So in order to move and really do well at division, you have to be familiar with what multiplication is. You cannot really do division until you know what multiplication is. So if you don't know that really well, go back to the multiplication section and review that, okay? So let's go ahead and get started. We're going to talk about division, and the problems you're going to have are going to look something like this. And I'll explain as we go along here. 6, and there's going to be this symbol here, like this, divided by 3, okay? What this means is 6 divided by 3. What does that really mean? Another way that you'll see this problem written, okay, is kind of like this. You'll have 6 underneath this kind of house looking thing, and then you'll have a 3 here, okay? What does this mean, okay? You're taking 6 and you're dividing into it 3. Well, what it really means is the following. You have 6 balls. Okay, 6 balls. That's the 6 here, 6 balls, okay? And what it's really asking you is, how many times can the number 3 be divided into these balls? A better way to say that is, how many groupings of 3 can you chop this thing up into? Let me go ahead and just kind of show you what I'm talking about here. What we have is we have 6, and we're trying to figure out how many times the number 3 will divide into 6, okay? So what it's really asking you is, if I were to group this number into groups of 3, okay, here's a group of 3, and the reason I'm picking 3 is because 3 is in the problem, okay? And then over here you see here's another group of 3, okay? So what it's asking me is, if I take the number 6 and I divide it up into groups of 3, okay, how many groups would I have? That's exactly what division is, okay? You take the number that you're given, okay, and you chop it up into groups of however many you're dividing by, okay? And the question is, how many groups would you have? Well, you see right here, here's one group, okay, and here is another group. So there are two groups of 3, okay? So the answer is 2, okay? That is the answer to this problem, 2. The answer is 2, okay? And I'm just showing you, kind of graphically on the board exactly what it really means, and we're going to work a lot of problems and you'll understand it. But basically, in the biggest possible sense, division is you take the number that you're dividing into and you write it down, okay? And this is how many things I have. And then you chop it up into groups of however many you're dividing by, okay? So in this case, I chopped it up into groups of 3. And the question is, how many groups do you have? How many times can 3 be divided in evenly into the number? 1 group of 3, 2 groups of 3. So the answer is 2. 6 divided by 3 is 2. Now, if you remember back to my lesson on multiplication, this should seem a little bit familiar because when I explained multiplication to you, I told you that multiplication is, 3 times 2 gives you 6, for instance. That what it's telling you is the first number is how many groups of something do you have. The second number is how many things in each group. And it's a shortcut for addition, right? So when you take 3 times 2, you get 6, okay? Notice that there's a little bit of similarity here. 3 times 2, as you already know, is equal to 6. And I told you before that multiplication means that you have 3 groups of something, and in each group you have 2 things, and when you do this multiplication and you add everything together, you get 6 objects. Here, I'm kind of talking about groups and objects and everything else. What I'm trying to really tell you is that multiplication and division are very, very related to each other, and that's why I told you you need to understand multiplication first, okay? So multiplication and division are kind of opposites of one another, okay? They're basically opposites of one another. You're going to use multiplication in order to solve your division problems, okay? So, what I'm trying to tell you here is that if you know that 3 times 2 is 6, you also know that 6 divided by 3 is going to give you 2. You see, it's very related to each other. You also know that 6 divided by 2 is going to give you the other number, 3. So once you know the multiplication, you already know the division, okay? Because they're the same thing. You see, I've chopped up my number into groups and I've counted the number of groups, and that's how I'm dividing. I'm doing multiplication backwards, okay? That's what I'm doing. So if I know that 3 times 2 is 6, I know that 6 divided by 3 gives me the other number, 2. And I know that 6 divided by 2 gives me the other number, which is 3, okay? All right, so let's go ahead and use this knowledge and move on. We're going to do a lot of problems. We're going to work up to this. But the thing to remember is you've got to know your multiplication. If you know multiplication, division is not going to be hard, okay? So the next thing I want to do is I want to pick another problem. What if you have 8 divided by 4? Okay, what's the answer? Well, that can also be written in the following way, 8 divided by 4. What you're doing is you have a number, and then you want to chop that number into groups of 4 and figure out how many groups do you have, okay? All right, so another way you can do that is you can say the following, okay? Because multiplication and division are related, you can kind of treat this problem in the following way. You can say 4 times what number equals 8. That is what division is. When you see a problem like this, which most of the time you're going to see it like this, the way you read it is exactly like this. 4 times what gives me 8. And that's why your times tables are very, very important. 4 times what is 8, okay? Just think about it for yourself. You have to think of your times tables. 4 times 1 gives me 4, okay, so that's not it. 4 times 2, thinking to your times tables, gives you 8, okay? So 4 times what number gives you 8? Well, we just said the answer is 2. So the answer is 2, okay? That is the answer to this division problem. 4 times what gives you 8? Well, 2 is the answer, and there you go. Now, let me go ahead and show you now that we now that you know what the answer is, Okay, let me go ahead and show you why it's true. If you take your 8 balls, 1, 2, 3, 4, 5, 6, 7, 8 balls, that's what you start with, and you're going to divide it up into groups of 4. Okay, here's a group of 4, like this, and here's a group of 4, like this. I've taken my 8 balls and I've divided it up into a group of 4 and a group of 4. Question is, how many groups do you have? How many times can 4 be divided in? Here's one group, here's 2 groups. So the answer is you can do that 2 times. And that is what division is, okay? This is what it is graphically, but in reality, when you're working the problems, all you have to do is you have to say, take this number, 4 times what will give me 8? And the answer in this case was 2. So that's all you have to do, just write 2 down. So if you know your multiplication tables, division is not going to be hard. If you are not so good at your division tables, then you need to practice, because it'll just make everything a lot easier. What if you have 12 divided by 3? Okay, 12 divided by 3. Another way to write this problem is 12, put this division symbol over the top, and you put a 3 out here. So 12 divided by 3, okay? So what this question is asking is, start with this number, 3 times what number is equal to 12? 3 times what number is equal to 12? That is going to be the answer to this problem. 3 times what number is going to be equal to 12, okay? So let's go through our times tables. 3 times 1 gives us 3. So that's not right, because I'm looking for 12, right? 3 times 2 gives us 6. Okay, we're getting closer, but we're not there yet. We're looking for 12, okay? 3 times 3 gives us 9, right, from our times tables. And that's not right, because we're looking for 12. 3 times 4 gives us 12. Bingo, we hit the answer. 3 times 4 gives us 12. So the answer is going to be 4. 3 times what number is 12? 3 times 4 is 12. 4 is the answer, okay? So you can say the answer is equal to 4. Now, I want you to get in the habit right now of putting the answer up above this line here. So we're going to write the answer up there. That's all we're going to do. We can write the answer out down here. We can write the answer over here. We can write the answer over here. But you will see later, you just have to trust me, it's very helpful and it's correct to put the answer up here. So we're just going to write the answer there. So all this means is 3 times 4 gives me 12. That's all it means. 3 times 4 gives me 12. That's all division is, okay? Now that we have the answer, now that you understand what the answer is, let's go ahead and see how to do that by drawing circles, okay? We need to draw 12 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 circles. And we're dividing by 3. So we want to make a group of 3 here. There's a group of 3. I want to make another group of 3 here. Okay. We want to make another group of 3 here. Okay. And we want to make another group of 3 here. So we're dividing by 3. We're making groups of 3. Okay. The question is, how many groups do we have? 1 group, 2 groups, 3 groups, 4 groups. 4 groups of 3 items. So the answer is 4, which is exactly what we had before. The answer is 4. The answer is 4. Okay, so I'm not going to do this graphical stuff every problem. I just wanted to kind of show you what it means, okay? But in the end, if you know your multiplication tables, you're going to know how to do division. And that's the good news. That's why you have to memorize these multiplication tables. But once you know them, then your problems are going to be easy, because really that's all you have to know. Okay, so let's go ahead and do some other problems. What if they give you 9 divided by 3? Okay, 9 divided by 3. First thing we're going to do, just like we do for addition, subtraction, multiplication, and so on, we're going to rewrite the problem into a way that's going to help you, okay? So we have to put 9 underneath the house here, divided by 3. So whatever you're dividing into goes underneath, whatever you're dividing by goes on the outside, like this, okay? So the question is, okay, 3 times what number is going to give me 9? 3 times what number is going to give you 9? So if you don't remember off the top of your head, that's okay. Just start from the beginning. 3 times 1 gives you 3. That's not right because we're looking for 9. 3 times 2 gives you 6. That's not right because we're looking for 9. 3 times 3 gives you 9, and that's correct, okay? So what we want to do is say 3 times what number gives me 9? 3 times 3 gives me 9. So the answer is 3, okay? The answer is 3, okay? Now, that is the answer. That is the answer. You can circle that. But I'm going to go ahead and show you at this point what to continue to do in your problems to prove to yourself that that is the answer, because as we get farther along, it's going to be very, very important. Just follow along with me and I think you'll understand, okay? Go ahead and take, once you say, okay, 3 times 3 gives me 9, to check it, let's go ahead and check it for ourselves, okay? So let's do that. Let's multiply. 3 times 3, okay, is going to give me 9. So what I'm going to do is I'm going to go ahead and write a 9 underneath here. Okay, I'm going to have a 9 underneath there, because 3 times 3 gives me 9. So I'm going to write that down, and now I'm going to subtract these two numbers. 9 minus 9 gives me 0. Okay? So what I have is I have a remainder, what I'm going to call a remainder of 0. Okay? What that means is I've fully divided everything, okay? It means I started with 9, I divided 3 by 3. And the answer I got was 3, and I had no remainder. That means that there's nothing left over, okay? I divided by 3, and I got the answer of 3. And because of what I did here, I proved to myself that there's nothing left over. In other words, 3 was able to be divided into 9 an even number of times with nothing left over. And that's all it means, okay? So I want you to get in the habit of, once you put what you think the answer is up here, go ahead and multiply and then subtract. And when you get a 0 here, then the remainder is 0, and that means there's nothing left over. Okay? It means there's nothing left over. Okay, let's continue on. You'll see, you'll understand this remainder stuff and you know, as we go along here. 10 divided by 5. Okay, what would that be? First thing you do is rewrite the problem. You put 10 underneath the house and 5 on the outside because you're dividing by 5. Okay? Question is, 5 times what number will give you 10? Okay? 5 times what number will give you 10? Well, 5 times 1 will give you 5. Well, that's not right because we're looking for 10. Okay? 5 times 2, okay, is going to give you 10, right? And that's what we want. 5 times 2 is going to give us 10. Okay? So what I'm going to do is I'm going to put a 2 up here because that's going to be our answer. And notice I'm writing the 2 above the 10 here. I'm not putting it above the 1, I'm putting it above the 0 because we have divided 5 into this entire number, so it's got to go above this rightmost digit here. Okay? So 2, we believe that 2 is the answer. Okay? Now let's check ourselves. Let's make sure. Let's multiply. 2 times 5 gives us what? It gives us 10. So we're going to write 10 down here, okay? Because 5 times 2 gave us 10. And what we're going to do is we're going to subtract these two. 0 minus 0 gives us 0. 1 minus 1 gives us 0. So the remainder, which I'm going to put as an R, is 0. Okay? So the answer to this question is 2. That is the answer to the problem. And there is a remainder of 0. And that just means that when you take 10, you divide by 5, you get the answer of 2, okay? And there's nothing left over. So it was divided in an even number of times with nothing left over, which is good, okay? So that means that we've gotten the correct answer, okay? That means that we have gotten the correct answer, okay? Now we're going to work up in difficulty into the problems here, okay? And I think you'll find it quite easy as we go along. 15 divided by 3. First thing we need to do is rewrite this in terms of the problem. This is the way we always want to write our division statements here. 15 divided by 3, we're going to change it around. We're going to write it as this. 15 goes under the house, and 3 goes on the outside. So just like before, we're trying to figure out 3 times what number, and we're going to put that number right here over the 5, okay, is going to give us 15, okay? What number is that going to be? 3 times what gives us 15? Well, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15, okay? 3 times 5 is 15. So 3 times what is 15? 3 times 5 is 15. So we believe that 5 is the answer, but let's go ahead and just make sure, okay? Let's make sure. So let's multiply 3 times 5, and I'll go ahead and do it in another color here. 3 times 5, 15, okay? So I'm going to write it down. We're going to subtract. 15 minus 15, it just gives us 0. Okay, so the remainder is 0. So what this means is we've taken 15, we've divided by 3, and we got the answer of 5. And there's no remainder. So that means that there was nothing left over, okay? So if we were going to do this one graphically, we would draw 15 circles. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'll put one over here for 15. There's 15 circles on the board, and we're going to divide by 3. Here is one group of 3. Here's another group of 3. Here's another group of 3. Here is another group of 3. And here's another group of 3. Okay? One group, two groups, 3 groups, 4 groups, 5 groups, 5 groups, 5 groups of 3. And notice that there are no more leftover zeros out here. In other words, all of the zeros I had, I could group them in a group of 3. There's no extra 0 out here, okay, or a ball out there, or whatever we're talking about. There's no extra 0 out here. So that's because the remainder is 0, okay? The remainder is 0. I was able to divide everything up and put it into a group, and I had no more balls left over. So that's why the remainder, remainder means what is left over, is 0. Okay? And a little bit later, we're going to get into some problems where the remainder isn't 0, is whenever you have some things left over. But we're not there yet. Let's say you have 21 and you divide by 7. Okay? First thing you do is you write that as 21 underneath the house and 7 on the outside of the house. Okay? So, what we're trying to do is we're trying to divide 7 into 21, and we're going to put a number over here, and I'm trying to find out 7 times what number is going to give me 21. 7 times what number is going to give me 21? So let's go to our times tables. 7 times 1 gives you 7, but that's not right because I'm looking for 21. 7 times 2 is going to give you 14, but that's not right because I'm looking for 21. 7 times 3 is going to give us 21. So that's the answer, okay? Because what I'm looking for is 7 times what number gives us 21? 7 times 3, according to our times tables, is going to give us 21, okay? So we think this is the answer, and that's perfectly fine, okay? But let's go ahead and make sure. 3 times 7 is going to give us 21, and I'm going to write it down here, okay? 21 minus 21 gives us 0, okay? So there's a big fat 0. So what this means is the remainder is 0. So if I were to write 21 circles out and I would divide by 7, then I would have 3 groups there, and there would be no balls left over because I'm able to divide in evenly. There's no remainder, okay? Now we've gotten a great introduction to division. We've gotten a great introduction to division. We know how to divide. Congratulations, you know how to divide. Now we're going to get into some problems when the remainder is not 0. And it's going to be really, really easy. There's going to be no tricks or no problems or nothing really confusing here. So let's just go ahead and do it and take a simple problem first. Let's say you have 7 and you're going to divide by 3. Okay? 7 divided by 3. Well, what I'm going to do is I'm going to write the problem just like before, 7 divided by 3. And it's the same question as before. There's nothing different here. What you're doing is you're saying 3 times what number, which I'm going to write up here, is going to give me 7. 3 times what number is going to give me 7? Let's just go ahead and see if we can figure that out, okay? 3 times 1 is 3. That's not right because we're looking for 7, okay? 3 times 2 is going to give me 6. But that's not right because I'm looking for 7. 3 times 3 is going to give me 9. That's not right because I'm looking for 7. You see you have a problem here, okay? Because 3 times 2 is 6, so that doesn't really work, okay? And 3 times 3 is 9, and that doesn't really work. So you might look at this and you might say, well, there's nothing here that can equal 7. 3 times nothing will equal 7, okay? That's true, that's exactly right. So what you have here is a case where the division isn't going to have, you're going to have something left over after the division. That's the bottom line here, okay? So in a case when you can't find out exactly the right number to multiply by to give you what's underneath, you just do the best you can, okay? You do the best you can. How many times will 3 go into 7 without spilling over, okay? 3 times 2 would give us 6, okay? And that's just under 7, okay? 3 times 3 would give us 9. Well, that's too many because I didn't even have 9 to begin with, okay? That's too many. So what you want to do if you can't find a number to exactly equal is you just find the best number you can just underneath what you're looking for. So in this case, 6. 3 times 2 gives us 6. 3, we know that 3 will go into 7 2 times, and that'll give us 6. And we'll see. Well, let's just see what happens when we do that. We'll go through the problem, okay? For right now, we're just going to work it like this. We're going to say 3 times 2 is going to give us 6. So what we do is we do just like we did before. We're going to put the 2 here, and we're going to say 2 times 3 is going to give us 6. Okay? We're going to put a line there, and we're going to subtract, just like we did before. Okay? 7 minus 6 is going to give you 1. You all know that. Okay? Now, when you have a number down here below, remember in all the other problems we had a 0, but now we have a 1. Okay? So the question is, can 3 go into 1? Okay? That's what you need to ask yourself next. Okay? Can 3 go into 1? Well, here's one ball. Okay? And the question is, can 3 go into 1? Okay? Can 3 be divided into 1? The answer is no, because remember, division is kind of like you're making groups of 3 in this case, right? Well, if you only have one ball, you can't make a group of 3, okay? You can't even make a single group of 3, so you just can't do anything else, okay? So anytime you have a number and you're dividing into that number and the number that you're dividing into is less than the number that you're dividing by, you can't do that. You just can't divide anymore, okay? So basically you stop at this point. Okay, I'm going to erase this, and I'm taking this quite slow so that we make sure we understand. You basically stop at this point and say, okay, the remainder was equal to 1. That's why I had you do that before. The remainder is equal to 1. So when you write the answer to this problem down, the answer will be 3 divided by 7 is 2 with a remainder of 1. Okay? 2 with a remainder of 1. Now let's see why that's the case. Here, let's draw 7 balls. This is 7 balls. 1, 2, 3, 4, 5, 6, 7. 7 balls. Now let's divide by groups of 3. There's one group of 3. There's 2 groups of 3. Okay, I can't make another group of 3 because I don't have any more balls. Okay, so I just leave him out here. So what this is telling me is when I divide by 3, here's one group of 3, 2 groups of 3, and 1 ball left over. That's what that means. Okay, that's what the remainder means. When I divide 7 by 3, I can only do it 2 times, and that's why I have the 2. Okay, but then I have one little ball left over, and that's called the remainder. Okay, so that's what you write down. 2 with a remainder of 1 left over. So all that means is that when you do this division, it doesn't go an even number of times. Okay, there's going to be something left over. Okay, we're going to work a lot of problems like this, so if you don't get it just yet, don't worry. What if you had 12 divided by 5? 12 divided by 5. Okay, first thing you do is you put 12 under the house and you put 5 out here. Okay? Now what we're trying to do here with the 12 is we're trying to say 5 times what number is going to give us 12. Okay? Well, you know that 5 times 2 gives you 10, and 10 is just less than 12. Okay? And 5 times 3 gives you 15, but that's too much. Okay? You don't want to put a number up here that's going to give you, when you multiply, it's going to give you more than what you started with. You want to pick the number that just gives you just less, just a hair less from what you're looking for. So that's why we're going to put a 2 here. Okay, 2 times 5 gives us 10, which is just less than what we're looking for. If you were to put a 3 up here, then you would have 15, and that's too many. I mean, you can't do that because you only had 12 to start with. So 3 times 5 would be 15. That's too many. Okay, so we put a 2 up there. And now let's go ahead and find what our remainder is. 2 times 5 gives you 10, so you always write the 10 down here, okay? And now you got to do some subtraction. 2 minus 0 gives you 2, and 1 minus 1 gives you 0, so you don't have to write that down. So we're left with a 2. Next thing you need to ask yourself is, can you divide 5 into 2? Answer is no, because 2 is just not enough. You have to, when you're doing division, the number underneath the house has to be bigger than the number outside because you're dividing into that number, okay? So 2 divided by 5, I could never make 5 groups because I've only got 2 things to begin with. So you can't do this division. You can't take 5 and divide it into 2. So basically you just stop, okay? You just stop and you say that the remainder is equal to 2, okay? And the remainder is equal to 2. So the answer to this problem would be 2 with a remainder of 2, okay? Now let's figure out why that makes sense, okay? Let's go ahead and draw 12 balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're dividing by 5. So here is a group of 5. Here is a group of 5. Okay? One group of 5, 2 groups of 5. So it can divide in 2 times, but there's 2 balls left over. And so that's exactly what that is, okay? So never forget, whenever you're doing this, you pick the best number you can so that when you take 5 times 2, it's going to give you a number just underneath the number that you're looking for, okay? So you have to use your multiplication tables. And then you do the subtraction, and you find out what your remainder is going to be. Okay. I'm going to do a few more problems here to kind of get the hang of it. So you see, remainder really isn't that hard. It just means how many things do you have left over after you do this division, okay? So let's say you had something like 39 divided by 6. So what you would do first would you would have the 39 underneath the house, and you'd have the 6 over here, okay? You'd have the 6 over here. So 6 times what is going to give you 39, okay? If there's a number that'll do that, then that's going to be the answer. And if not, then you just pick the best number you can so that you just get right under 39 there, okay? So let's just pick some numbers here. 6 times 5, let's just pick a number to start with. 6 times 5 would be 30. Okay, that's pretty close to 39, but let's see if we can get closer, okay? 6 times 6 is going to give you 36, okay? And that's even closer, so that's even better, okay? But let's see if we can get closer, okay? 6 times 7, okay, is going to give you 42, okay? 6 times 7 is going to give you 42. That's too much because we only started with 39, so we don't want that one. We want to get just close enough, okay, but not too much, okay? So 6 times 6 gives you 36, and that is the closest we can get. So we're going to put a 6 over here. As we're dividing into 39, we put it over the right-hand number there. And that's going to give you 36. Okay, so let's go ahead and see what our remainder is. 6 times 6 is going to give you 36. And we subtract this, okay? Let's see what our remainder is. 9 divided by 6, 9 minus 6 is going to give you 3. 3 minus 3 is going to give you 0, and so on. So the remainder is basically going to be 3 because you can't do any more divisions, you see. You try to take 6 and divide it into 3. You can't do that because this number is too small. You can't make a group of 6 things when you only have 3 to begin with, okay? So you can't do any more division here. And what you end up saying here is the remainder is going to be equal to 3. So the total answer to the problem is going to be 6 with a remainder of 3. Okay? 6 with a remainder of 3. Okay? Now what you would do to check this graphically is you could take and you could draw 39 circles all along the board. And you could divide it up into groups of 6, into groups of 6, into groups of 6. And what you would see is that you would have 6 complete groupings, okay? But there'd be 3 balls left over, okay? The 3 balls left over. And that's all remainder is. It's just how many things do you have left over, okay? We'll do a couple more here, and then we'll move on to more challenging problems. Let's say you have 43 divided by 10, okay? So we're going to write that as 43 underneath the house and 10 on the outside. Okay? So I'm taking 10, I'm dividing into 43. How many times can that happen? 10 times 1 gives you 10. 10 times 2 gives you 20. 10 times 3 gives you 30. We're getting close. 10 times 4 gives you 40. That's real close, okay? 10 times 5 gives you 50, and that's too many because we only have 43 to begin with. So 10 times 5 gives you 50. You don't want to use that. So 10 times 4 gives you 40, okay? So I'm going to put a 4 up here. We think that's as close as we can get, okay? So let's check. 10 times 4 is going to give you 40, and then we're going to subtract here. 3 minus 0 is going to give us 3. And 4 minus 4 is going to give us 0, so we're just not going to write that. Now you can't do any more division between this and this because this number is too small. You have 10 you're dividing in, and you only have 3 to begin with, so you can't do any more division. So we just say the remainder is 3. So the answer to this problem is 4 with a remainder of 3. 10 can go into 43 4 times with 3 left over. So it doesn't divide a complete number of times. You have 3 balls left over, 3 pencils left over, whatever it is you're dividing. Okay? One more problem in this section, and then we'll be done. Let's say you have 30 divided by 9. Okay? First thing we do is we rewrite things. We say 30 underneath here, and we're going to be dividing by 9. Okay? So, same thing. 9 times what gives you 30? Let's go ahead and try. 9 times 1 gives you 9. 9 times 2 gives you 18. 9 times 3 gives you 27. Now we're getting real close, okay? 9 times 4 gives you 36, okay? And that's too many, right? Because we only have 30. So let's go back a minute and let's say 9 times 3 gives us 27. So we're going to put a 3 up here because we're dividing by this number here. And we're going to go ahead and see what our remainder is. 3 times 9 is 27. Okay, now we need to subtract 27 from 30. We have start in the right-hand column as before, and we can't do the subtraction, so we're going to have to borrow. We're going to take 1 away from this 3, and we're going to give it to the 0, making him a 10. Now 10 minus 7, you can do on your fingers and say that's equal to 3. Okay, and 2 minus 2 is just going to give you 0, so you don't even need to write that down. Now, you have a number 3 down here, and you can't divide this 9 into that 3 any at all because you just can't, because this is a number that's too small. You're trying to make a group of 9 things, and you only have 3, so you just can't divide anymore. So you're just going to say the remainder is going to equal 3. So the total answer to the problem would be 3 with a remainder of 3. So basically all that means is if you were to take 30 balls and write them all down and make a group of 9 and another group of 9 and another group of 9, you could do that 3 times, but then after you do that, you're going to have 3 balls left over. Hi, and welcome to this section of the tutor where we're going to continue our work on division and part 2 of division. And the only thing different between this and the last section is going to be the problems are going to get a little bit bigger and there's going to be a little more steps involved. But the basic idea is the same. You're taking a number and you're trying to divide a number into it and you're trying to see how many times can you do that, okay? So let's go ahead and get started by working some problems, and we're going to build up in complexity here. What if you have 47 divided by 2? Okay, 47 divided by 2. Well, the first thing you do is you rewrite this problem and you put 47 underneath the house and 2 on the outside, okay, just like this. Now what you're doing is you're trying to divide 2 into 47, okay? And the way you do this when you look at a problem is certainly, I don't know off the top of my head how many times 2 is going to go into 47. So I'm going to show you the method that you use to go ahead and do this. The first thing you do is you take your 2 and you see, forget about the fact that it's 47 under here, okay? Just look at the first number, okay? Can 2 go into 4? Just without even looking at the 7, can 2 go into 4? In other words, 2 times what would give you 4, okay? 2 times what would give you 4? I think that you all know the answer to that is 2, okay? 2 can go into 4 2 times, okay? So let's go ahead and do that. Let's go ahead and see where that takes us. What we're going to do next is we're going to say 2 times 2, and we're going to multiply that, and we're going to get a 4 back. Okay? We're going to get a 4 back. Okay? And notice we haven't done anything with the 7 yet, so I'm just showing you the method here. The next thing you do is you subtract these two numbers. Okay? 4 minus 4. Okay? Well, that's going to give you 0. Okay? Like this. Okay? Now you're basically done here. You can't take 2 and divide it into 0 because, in order to do division, the number you're dividing into has to be bigger than this number. So you can't do any more division, okay? But you do have this 7 sitting out here. So what I'm going to do is I'm going to draw an arrow, and I'm going to put this 7 down here, okay? So you have 7, okay? Now the thing you need to ask yourself is, how many times can 2 go into 7? In other words, 2 times what gives you 7, okay? 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. Well, that's too many. You can't do 2 times 4 because that'd be 8 and that'd be too many. You're looking for something close to 7. So 2 times 3 is going to give you 6. That's as close as you can get. So what you're going to do is you're going to put a 3 here over the next column, okay? And you're going to keep going. You're going to multiply. Every time you put a number up here, you've got to multiply, carry it down, subtract. So 3 times 2 is going to give you 6, okay? Again, you subtract. 7 minus 6 gives you 1, okay? And then the final thing you do is you say, can you divide 2 into 1? The answer is no, because this is too small. It's smaller than the number you're dividing by. And on top of that, there's no more digits to bring down here to help you out to make that number any bigger. So you say you have a remainder of 1, just like we had in the other problems. So the answer to this problem is going to be 23 remainder of 1. So what this means is that if you take 47 and you divide by 2, then that will go in 23 entire times, but then you'll have 1 ball left over, okay? You can't go an even number of times, okay? So I'm going to review that one more time. When you look at a random problem like this, you take and you see if you can divide the number into the first number. Answer was yes, so we put a 2, we got a 4, and we subtracted. Okay? We can't divide 2 into 0, so there's really nothing else we can do there. So at that point, you take the next number and you drag it down and you stick it down there. Okay? Now, I can divide 2 into 7. Okay? I can do that. 2 times 3 is 6, which is pretty close to 7, but not too much. So 2 times 3 gave us 6. You subtract again. Again, we cannot divide 2 into 1. And there's no more numbers to drag down, so you're done. You can't do any more. Basically, you keep doing this until you get a number that you can't divide into, and until you have no more digits to help you, and then that's your remainder. Okay? So you're doing all of this to find your remainder. Okay? It's not that hard, but it does take some practice. So let's go ahead and work some more problems. What if you had 55 divided by 3? Okay? So you have 55, and you're going to divide by 3. Same thing as before. First thing you're going to do is just see, can you divide by this first number? Okay, can you divide by that first number? Well, 3 times 1 gives you 3. 3 times 2 gives you 6, but that's too much because I'm just looking at the 5. 6 is too big. It's bigger than 5. So I'm going to go ahead and put a 1 here because 3 times 1 gives me 3. So I'll put the 3 right below, like this. Okay? And I subtract only these numbers here. 5 minus 3 gives me 2. Okay? 5 minus 3 gives me 2, so you have a subtraction sign there. Now, next thing you do, can you divide 3 into 2? Well, the answer is no, because this is too small. But what you do have is you have an extra digit here, which we're going to drag down, and we're going to put down as 5. Now I have 25 down here. Can you divide 3 into 25? Okay? Can you divide 3 into 25? Well, let's think about it for a second. 3 times 5 is 15. 3 times 6 is 18. Okay? 3 times 7 is 21. And 3 times 8 is 24. That's as close as we're going to get, because if you go past that, you're going to be too many numbers. Okay? So let's say 3 times 8 is going to give us 24, and that's as close as we're going to get. So we put an 8 up here on the next digit. And in order to find the remainder, we have to keep on multiplying and subtracting like this. So 8 times 3 is going to give you 24. Okay, and you're going to do another subtraction. So in order to subtract this, 5 minus 4 just gives you 1. 2 minus 2 gives you 0, so you don't need to write that. Then the next thing you need to ask yourself is, can I divide 3 into 1? The answer is no, because this is too small. You have to have a number bigger than this number in order to divide. So you can't divide anymore, and you don't have any more digits to help you out to make the number any bigger, so you're done. So you just say, okay, the remainder is 1. So the total answer to this problem is 18 with a remainder of 1. Okay? 18 with a remainder of 1. Okay? Now I also want to point out briefly that with every single one of these problems, you can check your answer. Okay? You can check your answer to every single one of them. Because what did we say before? What this number up here is telling you is kind of like 3 times what number is going to give you 55. Okay, that's kind of what we did. And we also have a remainder out here. So let's say we take 3 times 18 and see what happens. We're going to take 3 and multiply by 18. We're going to see what it comes out to. So let's do this. 8 times 3, remembering back from multiplication, is 24. So we've got to put a 4 up there, 4 down there, and the 2 up there for 24. And then 3 times 1 is 3, plus 2 more gives us 5, 54. Well, you may look at that and say, well, I got 54 here, and I'm trying to equal 55. But don't forget, you have this remainder. That means that 3 could go into 55 18 times, but there was 1 left over. Okay? So when you check the problem, you have to multiply this, and you have to add the remainder back in because that was left over. And that gives you the 55, which agrees with what you had to begin with. So you know that you have the right answer. And you can do that with every single division problem. You can always check your answer. And so I think that you should do that. I think that for every problem you do, that you should check your answer and make sure that it's right. Okay, now let's say the next problem that you would have would be something like 87 divided by 6. Now, like with all of these problems, the first thing you're going to do is write your 87, what you're dividing into, underneath the house here, and you're going to write your 6 on the outside. That's what you're trying to divide in. Okay, so you're going to have that on the outside, and you're going to be dividing by 6 here. Okay, so the first thing you're going to do, I don't know what 6 times what would equal 87. Okay, 87 is a pretty big number. Okay, and I don't know off the top of my head what times 6 is going to equal 87, so we're going to use this, we're going to break this problem into pieces, and we're going to solve it like that. So the first thing we're going to do is we're going to see how many times does 6 go into the 8, just the 8 by itself. And so you can kind of think about that. Well, 6 times 1 is 6, and 6 times 2 is 12. Well, 12 is too big because we're just looking at trying to divide into 8 right now. So you're going to have to go with 1, okay? So we're just going to put a 1 up here, and in order to go ahead and continue on with the problem, we're going to say 1 times 6 is going to give us 6, okay? And so we're going to put it down like that. And then the next thing you do is you just go ahead and subtract these two numbers. You don't worry about the 7 at this point. 8 minus 6 is going to give you 2, okay? 8 minus 6 is going to give you 2. And the next thing you do is you look at this number and say, can I divide 6 into 2? And the answer is no, because 2 is too small, okay? You're trying to divide 6 into 2, and you just can't do that because if you're going to divide into something, you have to be dividing into a number bigger than you are, okay? So you can't do that, but you do have the 7 sitting over here. And so what we're going to do is we're going to drag that 7 down, okay? And we're going to put it right here. And we're going to make it a 27. So when we did that initial subtraction, we couldn't go any further because this 2 is smaller than 6. So we just drag the 7 down and make it a 27. So then the next question is, for what number we're going to put up here? 6 times what is going to give us 27? We're going to try to divide 6 into 27. So you just go through your multiplication tables. Pick a starting point and just go from there. So I know that 6 times 4 is going to be 24, okay? And 6 times 5 would be 30. Well, 30 is too big because we're looking at trying to go up to 27. So I back off a little bit and I say 6 times 4 gives me 24. So that's as close as I'm going to get, okay? And I put the 4 up here, just like this, okay? 6 times 4, go ahead and multiply. 6 times 4 gives us, as we already said, 24. So I write it down like this. And again, I do another subtraction. In this column, the 7 minus the 4 is going to give me 3. Okay, and you can kind of think, starting at 7, 6, 5, 4, 3. Subtract 4, we got a 3 here. And 2 minus 2 is going to be 0, so I don't even have to write that out here, okay? So again, you go through the same thing. You've got a number down here. You say, can I divide 6 into 3? Answer is no, you can't, because 3 is smaller than 6, okay? There aren't any more digits to drag down here to help you out, so you're basically done. The remainder is going to be equal to 3, okay? So the final answer to this problem is going to be 14 with a remainder of 3, okay? 14 with the remainder of 3. And you know, what this really means here is that you take 6 and you try to divide it into 87. It's not going to go an even number of times. It can go 14 times. Okay, you can do a group of 6, a group of 6, a group of 6, a group of 6, you know, into 87. And you can do that 14 times. But when you get to the last one, you're going to have 3 balls or pencils or whatever it is left over, and you're not going to be able to do anything with that. So it's just called a remainder, okay? Now again, I want to encourage you guys to always check your work, okay? Always check your work, because any division problem, you're always going to be able to see if you can have the right answer. So remember back in the beginning when I introduced division, what it is we're trying to do is we're trying to say 6 times whatever is up here is going to equal what's under here, and then don't forget we have a remainder. So let's go ahead and try to do that. Let's say 14 times 6. Let's multiply these two numbers together and see what we get. Well, 6 times 4 is going to be 24, so I'll put the 4 there and the 2 up in the other column. And then working on this column, 6 times 1 gives me 6, plus the 2 I just wrote down. 6 plus 2 gives me 8, so that's an 84. Now notice that it doesn't equal what's on the inside. Well, that's because we had a remainder, okay? That's because we had a remainder. Anytime you have a remainder, you're going to have to add that remainder back in, like this, and then in the end of the day, when you do that, you should get what you started with in the problem. And so what's what we have here? 84 plus 3 is 87. So what this means is that when you take the 6 and multiply by the 14, you get 84, okay? And you have to add those 3 extra balls back in that were left over, and then you'll get your 87. And that's how you check these kinds of problems with remainders. If your remainder is 0, which is a lot of the kind of problems we were doing in the beginning, then when you multiply these two numbers here, you should always get exactly what's in the center here in those cases. And those cases are the cases where you don't have any remainder, okay? So it's basically very, very easy to check your work here. You're just going to have to use your multiplication skills. Now again, we're going to go ahead and work through a lot of these problems because division is really one of the toughest areas a lot of people have problem with, and you're just going to have to work through some problems. 157 divided by 5. We go ahead and write 157 here, and we put a 5 out front, okay? Now, what you're really trying to do is you're trying to say 5 times what number is going to give you 157, and you may have a remainder to add in, but in the end of the day, you're trying to get 157. Now, I certainly don't know off the top of my head what that number is, so let's work through it. When you're confronted with something like this, the first thing you should do is say, well, let's go into the first digit. Can I take 5 and divide it into 1, okay? The answer is no, you can't do that, because division, remember, is taking something and breaking it up into groups of whatever this number is and going from there. So if I have 1 ball, okay, which is what I have here, if I'm looking at this digit, I can't make a group of 5 because I've only got 1 ball. So you really can't even do that. So you really can't work with this first digit here because it's less than this digit. So just go ahead and move on. Look at both digits together, which is 15. Can you take 5 and divide it into 15? Of course you can. Okay, 5 times 3 is 15. So you know you're off to a good start. So we tried to look at the first digit. We couldn't divide it because this is too small. It's smaller than the number you're dividing by. And we go ahead and expand our view and look at the 2 digits, and we say, sure, 5 times 3 is 15. So let's go ahead and work through it. 5 times 3 is 15. Okay, we subtract, we're going to get 0 here. Okay. Now the next thing you do, just like always, is you say, well, can I take 5 and divide it into 0? Of course you can't, because 0 is less than 5. You can't divide a bigger number into a smaller number. So you really can't do anything there, but you have this 7 here, which is always the next thing you should be looking at, and you go ahead and drag that 7 down here, okay? So next thing you ask is, can I take 5 and divide it into 7? how many times will 5 go into 7? Well, 5 times 1 is 5. That's one time. And 5 is pretty close to 7. 5 times 2 is 10, but that's too much because that's greater than 7, so you can't do 5 times 2. So let's go backtrack a little bit, and we'll say 5 times 1 gives us 5. 5 times 1 gives us 5. Okay? And then we're going to go ahead and do our subtraction like we always do in these problems. 7 minus 5 you can do on your fingers, and you'll see that that gives you 2. Okay? And we go ahead and try again. 5, can we divide into 2? No, you can't because it's too small. It's less than 5. And there's no more digits here to drag down and help you out. So what this means is you're going to have a remainder of 2. Okay? So the final answer to this problem would be 31 with a remainder of 2. Okay? 31 with a remainder of 2. So that means when you take 5 divided into 157, it's going to go 31 times evenly, but then you're going to have two guys left over, and that's why it can't divide a whole number of times in there, because you're going to have 2 guys left over there. You're going to have a remainder. Okay? Okay, we're going to go ahead and work up in complexity here. 298 divided by 8. Okay, first we're going to rewrite the problem, and we're going to say 298 underneath the house. We're going to divide 8 into that. Again, just like before, see if you can divide 8 into 2. Try the first digit. Answer is no. 2 is too small. You have to be dividing into a number bigger. So let's go ahead and expand our view. Let's look at 29. Can we divide 8 into 29? Well, sure you can, because 29 is bigger than 8. Let's see how many times we can do that. 8 times 1 is 8. That's pretty small. 8 times 2 is 16. We're getting closer, but we're not there. 8 times 3 is 24. We're getting real close to 29. 8 times 3 is 24. 8 times 4 is 32. Well, that's too big. You can't use that one. That was too big. We've already blown our limit. So let's go back and say 8 times 3 is going to give us 24. So we write that down, put a subtraction sign. And then we're going to go ahead and subtract and go from there. 9 minus 4 is going to give us, on your fingers, you can make sure you remember that that's 5, and 2 minus 2 gives you 0, so I'm not even going to write that. Next thing you do is you say, can you divide 8 into 5? You can't do that because 5 is less than 8. So we take and we drag this 8 down and make it 58. Now you say, can you divide 8 into 58? Well, sure you can. 58 is bigger than 8, so you can do that. Let's figure out if we can do that. Let's continue on. 8 times 4 gave us 32. 8 times 5 gave us 40. That's pretty much, that's a lot less than 58, okay? 8 times 5 is 40. 8 times 6 gives us 48. Getting closer. 8 times 7 gives us 56, and that's going to be as close as we're going to be able to get. 8 times 7. 8 times 7 is going to give us 56. Okay? You do your subtraction. 8 minus 6 gives you 2. 5 minus 5 is just going to give you a big fat 0, so there's nothing else you can do there. You ask yourself, can you divide 8 into 2? No, you can't, because 2 is too small. You've got to have a number bigger here than what you have up here. So you can't do any more division, and you don't have any more digits to help you out. So this is going to mean you're going to have a remainder of 2. Okay? So the final answer to this problem is going to be 37 with the remainder of 2. With the remainder of 2. Now I'm going to leave it to you yourself here. You can pause the video and practice this here. But to check this, all you have to do is take 37 multiplied by 8. So you could take 37 and multiply by 8, and you'll get some number. Okay? And then you add your remainder back in to that number, and you should get 298. Okay? So that would be how you would check these problems. All you have to do is multiply the answer that you got by what you were dividing by, and add whatever remainder that you have, and then you should be able to check your answer. Moving on here, let's say you had 504 divided by 3. So you'll have 504 divided by 3. Okay? So, just like always, we see, can 3 go into 5? Well, sure it can. 5 is bigger than 3, right? How many times will 3 go into 5? Well, it's only going to go one time, because 3 times 2 is going to give us 6, and that's too big. So let's say 3 times 1. 3 times 1 is going to give me 3. So I draw a line, and I do a subtraction. 5 minus 3 gives me 2. Okay? So now I ask myself the question, can 3 be divided into 2? Well, no, it can't, because 2 is smaller than 3. You can't do that. So I'm going to drag this 0 down, and I'm going to make it bigger. And now I can do that. I can take 3 and divide it into 20. Okay, I can do that because 20 is bigger than 3. How many times will it go? 3 times, let's say 5 is 15. Okay, getting closer. 3 times 6 is 18. Okay, we're getting pretty close. And 3 times 7 is going to give you 21, and that's too big. You can't use that. So let's go back to 3 times 6. 3 times 6 giving us 18. Remember, we were trying to divide the 3 into the 20. We're going to say it goes 6 times evenly. Okay, 3 times 6 gives us 18. Let's go ahead and do this subtraction. Okay, you probably know that 20 minus 18 is just going to give you 2. Okay, but if you don't remember that, you can just do the subtraction here. Because you have a 0 up here, we're going to borrow from the 2, make him a 1. I'm going to put a 1 here and make him a 10. So I'm going to take the 1 from the 2 and give it to the 0, making him a 10. Now, 10 minus 8 is going to give you 2. And 1 minus 1 is going to give you 0, so you don't even have to add that in there. Okay? So now, continuing on, can 3 be divided into 2? No, it can't, because 2 is too small. So I'm going to take this 4, and I'm going to bring it down here. I'm going to make it 24. Now I can do this division into 24. How many times will it go? Well, if you think about it, you'll realize that 8 times 3 is 24. So 8 times 3 is 24. So it goes an even number of times, and that would be 8 times. So 8 times 3 is going to give you 24. 24 minus 24 gives you a big fat 0. So that means that the remainder is 0. So there is no remainder in this problem. There is no remainder in this problem. So when you take 504 divided by 3, you're going to get 168. Okay, you're going to get 168. And it goes an even number of times with no remainder. And if you want to check your answer, which I think you should always do, then all you would have to do is say 3 times 168. Okay, and you should get 504. Let's multiply here. 8 times 3 is 24. So I'm going to put my 4 here and my 2 up here. Now let's multiply here. 6 times 3 is 18, right? 18. Plus the 2 I just wrote here is going to give me 20. So I'm going to put the 0 there and the 2 up there. Okay? 1 times 3 gives me 3. Plus 2 more give me 5. 504 checks with 504. So I have checked the answer. Remember, in the end of the day, when you do this, what you're trying to figure out is what number do you multiply by that would give you underneath what you're looking for here. Okay? Let's go ahead and continue working some challenging problems. Let's say you have 238 divided by 11. Okay? 238 divided by 11. And that's going to give you, let's go ahead and rewrite it, 238 divided by 11. Now, the only difference between this problem and the last problem is here you have a double-digit number. But the process is exactly the same. There's no difference here. There's nothing a lot harder about it. You just have to use your multiplication knowledge, okay? How many times will 11 go into 2? It's not going to happen because 2 is too small. So let's go ahead and expand our search. How many times will 11 go into 23? Okay? Well, if you remember your times tables and you go back and you look at your 11 times tables, that's going to go in 2 times. Okay? And let's figure out the reason why. The reason why is because 11 times 2 gives you 22. And if you forget how to do that, just multiply 11 times 2. 2 times 1 gives you 2. 2 times 2, or 2 times 1 gives you 2. So 11 times 2 is 22. That's all I'm doing here. Okay? Nothing special. Okay? Now, 22 is pretty darn close to 23. So that's exactly as far as we can go. So that's the right number, 11 times 2 here. So let's go ahead and do a subtraction. 3 times 2 is going to give you 1. Okay? 2 times 2 is going to give you 0, so you don't even have to write that here. So the next thing you do is you say, well, can 11 go into 1? Can 11 be divided into 1? Well, no, it can't because 1's too small. So let's drag this 8 down here and make it 18. Now, how many times will 11 go into 18? Well, I think you can convince yourself it's only going to go in one time, because 11 times 1 is 11, right? And 11 times 2, we already said was 22, and that's too big because we're looking for 18. So we're going to say it goes in one time. Now let's multiply. 1 times 11 gives you 11. Okay? So let's do our subtraction. 8 minus 1 gives you 7. And 1 minus 1 gives you 0, so you don't even really have to add that. Okay? So, since you don't have any other digits to bring down, and since you can't do this division, then you just say the remainder is 7. So the answer to this problem is going to be 21 with a remainder of 7. So 11 goes into 238 21 whole times with 7 left over. So you're going to have 7 guys left over there. And you could check it if you wanted to by saying 11 multiply by 21, okay? And then you add your 7 back into the answer, and you should get 238. Okay? So I'm just, basically working problems a little bit longer. Division really is challenging because it makes you use your multiplication, and that's what's really hard about it. But if you practice problems, which is what I'm doing with you here, I think you'll get the hang of it. Let's say 509 divided by 25. How would you do that? Well, first thing you're going to do is you're going to take 509, put it under the house, and you're going to put 25 outside the house. Okay? Now, can 25 be divided into 5? No, it can't, because 5 is too small. You have to be dividing into a number bigger, okay? Can 25 be divided into 50? Sure it can. 25 times what would be 50? 25 times 2. 25 times 2 is going to be 50, and let me show you how. 25 times 2. 5 times 2 is 10, so I'm going to write 0 here and put the 1 up here. 2 times 2 gives me 4, plus 1 gives me 5. So 25 times 2 does give me 50, and that's why I put it over there, okay? So because I know that 25 times 2 does give me 50, I can subtract and just put a 0 here. 0 minus 0 gives me 0, 5 minus 5 gives me 0, so I've got a big fat 0. Can 25 be divided into 0? Of course it can't, okay? It's just too small, so you're going to have to take your 9 and drag it down here, okay? Can 25 be divided into 9? Because these leading zeros, they don't really mean anything. Okay, so the next thing you do is you say, can 25 be divided into 9? Okay? The answer is, how many times can 25 be divided into 9? Well, 25 can go 0 times into 9, okay? In the previous problems, when we've been working on this, I specifically chose this problem to show you something very important. In the previous problems that we've worked, anytime the number down here, you couldn't divide it into it, basically I said, oh, that's just your remainder, okay? But in all of those problems, you had all the digits filled out above here. In other words, anytime you're doing a division problem, you're going to have, wherever you start dividing, like in this case we chose 50 and we put the number here, you're going to have to keep dividing and fill up digits above all of the digits in your problem, okay? So in all those other problems, you had these digits already filled out, and so whatever you were left with was just going to be a remainder. In this problem, we did everything properly, and we had a 9 left over, and 25 goes into 9 0 times. That's what I meant before when I said that, how many times can you divide it into it? And I said, no, of course you can't. Well, what I'm telling you here is the same thing. How many times can it be divided? 0 times, okay? I have a placeholder here. I've got to fill it out in order to finish solving this problem, so I'm going to put a 0 up there, okay? I'm going to put a 0 up there. Now, when I take the 0 multiplied by the 25, I'm just going to get 0, because 0 times anything is 0. So now, just like anything else, I do my subtraction. 9 minus 0 is going to give me 9. Now, since all of the digits are filled out up here, up until the last column, now I ask myself, can 25 go into 9? Well, no, it can't. So I say it's a remainder of 9. So the answer here is going to be 20 with a remainder of 9. It's very important for you to understand why we did that. Basically, wherever you start dividing, you're going to start putting numbers. In every problem you do, you're going to have a number over wherever you start up until the last column. Okay, so when you get down to a point when you're asking yourself, can you divide in there, okay, if you've got a digit available, you're going to have to go ahead and populate it with a 0. If there's no digit available, like in the end here, when we got down to this last one, we had all the digits filled up. So then when we asked ourselves again, could we divide into 9? Well, there's nothing else to do. We've already put all the digits down that we need to. So then we just say our remainder is 9. Okay? This kind of stuff is just going to come with practice. You can't really explain it in words. You just have to work problems, and that's why I'm picking these problems to try to help you. Okay. These are going to be, I think, challenging problems. Let's say you have 407 divided by 37. So all you do is you take your 407, put it under the house, and you're dividing by your 37. Okay, not that bad. Can 37 go into 4? No, it can't. Okay. Can 37 go into 40? Sure, it can. It can go one whole time. 1 times 37 gives me 37. Okay? Gives me 37. Now let's go ahead and do a subtraction here. In order to do the subtraction, I'm going to have to borrow, making this a 3, and I'll make that a 10. Okay? 10 minus 7 is just going to give me 3, and 3 minus 3 is going to give me 0, so I'm not going to have to write that down. Can 37 go into 3? Can 37 go into 3? Well, no, it can't. But before I put a 0 up here, before I do anything, I got to go ahead and drag down my next digits and then go ahead and ask myself, can 37 go into 37? Answer is yes, of course it can, one time. 1 times 37 gives me 37. And then, of course, you know 37 minus 37 is just going to give you 0. So there's no remainder. So the answer is just 11 in this case. 37 can go into 407 11 times. Okay? Now we're going to do one final problem. It's going to look really, really complicated. That's probably the hardest problem we're going to work here, and I'm just going to give it to you so that you can get some practice working a bigger problem. 5,283 divided by 24. So how will we do that? Well, just like always, 5283 divided by 24. So, can 24 go into 5? No, it can't, because 5 is too small. Can 24 go into 52? How many times can it do that? Well, let's see. 24 times 1 is going to be 24. 24 times 2, let's see what that would equal. 2 times 4 gives me 8, and 2 times 2 gives me 4, 48. I know that 48 is pretty darn close to 52, and so I think that that's going to be the right answer, and it is the right answer. So what you do is you just put a 2 over this column, because I've divided by into 52, and we just said 2 times 24 is going to give me 48. Okay? So I do a subtraction. Now in order to do this subtraction, I'm going to have to borrow, because 2 is too small on the top, so I'm going to put a 1 here. I'm going to make this a 4. Okay? So 12 minus 8 is going to give you 4. You can do that on your fingers. 12 minus 8 is going to give you 4. 4 minus 4 is going to give you 0, so I don't have to write it down there. Okay? Now, can 24 go into 4? No, it can't. But before I do anything else, I've got to try to drag down that next digit. Before you put any zeros up here, if you're trying to divide through, you've got to make sure and try to drag down that next digit over before you do that. Okay? So the question is, can 24 go into 48? Sure it can. We already just figured out that if it can go 2 times. 2 times 24 is 48. We just figured that out. Okay? So then we just subtract those two. 48 minus 48 obviously is going to give you 0. Can 24 go into 0? No, it can't. But before we put anything up here, we're going to have to drag our 3 down. Okay? We're going to have to drag our 3 down. Now that we have dragged our 3 down, we can ask ourselves, does 24 go into 3? Does 24 go into 3? No, it doesn't. But because I've got to put something here, because notice I started here with the 2 and I did here, I've got one more digit. In order for this problem to be complete, I've got to put something here, okay? And because I've already dragged down that next digit, 24 goes into 3 how many times? It goes 0 times, because it's too small. You can't even divide it, not even 1 time. So you just put a 0 here, just like in the other problem. 0 times 24 is going to give you 0, okay? And then 3 minus 0, as you know, is just going to give you 3. So that just means you have a remainder of 3 because there's no more digits to put up here. 24 can't be divided into 3, and there's nothing else to write. I've got all of my digits up here above all the columns here. So the answer is 220 with a remainder of 3. So in these problems, the most important thing to do is start and be careful about it. You take your number that you're dividing by, and you just look and see and kind of go look at the first digit and then the first 2 digits and so on, and see if you can divide in. If you can, go ahead and put your number, do your multiplication and subtract, and then just keep doing that, dragging down digits as you need, and keep dividing, dividing, dividing. Eventually, you'll get to a point where you can't divide anymore, and you've got all these digits up on the top. And then you have your answer and you have your remainder, and that is how you do long division. 1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is 2. 1 times 3 is 3. 1 times 3 is 3. 1 times 4 is 4. 1 times 4 is 4. 1 times 5 is 5. 1 times 5 is 5. 1 times 6 is 6. 1 times 6 is 6. 1 times 7 is 7. 1 times 7 is 7. 1 times 8 is 8. 1 times 8 is 8. 1 times 9 is 9. 1 times 9 is 9. 1 times 10 is 10. 1 times 10 is 10. 1 times 11 is 11. 1 times 11 is 11. 1 times 12 is 12. 1 times 12 is 12. 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6. 2 times 4 is 8. 2 times 4 is 8. 2 times 5 is 2 times 5 is 10. 2 times 6 is 2 times 6 is 12. 2 times 7 is 14. 2 times 7 is 14. 2 times 8 is 16. 2 times 8 is 16. 2 times 9 is 18. 2 times 9 is 18. 2 times 10 is 20. 2 times 10 is 20. 2 times 11 is 2 times 11 is 22. 2 times 12 is 24. 2 times 12 is 24. 3 times 1 is 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 2 is 6. 3 times 3 is 9. 3 times 3 is 9. 3 times 4 is 12. 3 times 4 is 12. 3 times 5 is 15. 3 times 5 is 15. 3 times 6 is 18. 3 times 6 is 18. 3 times 7 is 21. 3 times 7 is 21. 3 times 8 is 24. 3 times 8 is 24. 3 times 9 is 27. 3 times 9 is 27. 3 times 10 is 30. 3 times 10 is 30. 3 times 11 is 33. 3 times 11 is 33. 3 times 12 is 36. 3 times 12 is 36. 4 times 1 is 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 2 is 8. 4 times 3 is 12. 4 times 3 is 12. 4 times 4 is 16. 4 times 4 is 16. 4 times 5 is 20. 4 times 5 is 20. 4 times 6 is 24. 4 times 6 is 24. 4 times 7 is 28. 4 times 7 is 28. 4 times 8 is 32. 4 times 8 is 32. 4 times 9 is 36. 4 times 9 is 36. 4 times 10 is 40. 4 times 10 is 40. 4 times 11 is 44. 4 times 11 is 44. 4 times 12 is 48. 4 times 12 is 48. 5 times 1 is 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 2 is 10. 5 times 3 is 15. 5 times 3 is 15. 5 times 4 is 20. 5 times 4 is 20. 5 times 5 is 25. 5 times 5 is 25. 5 times 6 is 30. 5 times 6 is 30. 5 times 7 is 35. 5 times 7 is 35. 5 times 8 is 40. 5 times 8 is 40. 5 times 9 is 45. 5 times 9 is 45. 5 times 10 is 50. 5 times 10 is 50. 5 times 11 is 55. 5 times 11 is 55. 5 times 12 is 60. 5 times 12 is 60. 6 times 1 is 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 2 is 12. 6 times 3 is 18. 6 times 3 is 18. 6 times 4 is 24. 6 times 4 is 24. 6 times 5 is 30. 6 times 5 is 30. 6 times 6 is 36. 6 times 6 is 36. 6 times 7 is 42. 6 times 7 is 42. 6 times 8 is 48. 6 times 8 is 48. 6 times 9 is 54. 54. 6 times 9 is 54. 6 times 10 is 60. 6 times 10 is 60. 6 times 11 is 66. 6 times 11 is 66. 6 times 12 is 72. 6 times 12 is 72. 7 times 1 is 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 2 is 14. 7 times 3 is 21. 7 times 3 is 21. 7 times 4 is 28. 7 times 4 is 28. 7 times 5 is 35. 7 times 5 is 35. 7 times 6 is 42. 7 times 6 is 42. 7 times 7 is 49. 7 times 7 is 49. 7 times 8 is 56. 7 times 8 is 56. 7 times 9 is 63. 7 times 9 is 63. 7 times 10 is 70. 7 times 10 is 70. 7 times 11 is 77. 7 times 11 is 77. 7 times 12 is 84. 7 times 12 is 84. 8 times 1 is 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 2 is 16. 8 times 3 is 24. 8 times 3 is 24. 8 times 4 is 32. 8 times 4 is 32. 8 times 5 is 40. 8 times 5 is 40. 8 times 6 is 48. 8 times 6 is 48. 8 times 7 is 56. 8 times 7 is 56. 8 times 8 is 64. 8 times 8 is 64. 8 times 9 is 72. 8 times 9 is 72. 8 times 10 is 80. 8 times 10 is 80. 8 times 11 is 88. 8 times 11 is 88. 8 times 12 is 96. 8 times 12 is 96. 9 times 1 is 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 2 is 18. 9 times 3 is 27. 9 times 3 is 27. 9 times 4 is 36. 9 times 4 is 36. 9 times 5 is 45. 9 times 5 is 45. 9 times 6 is 54. 9 times 6 is 54. 9 times 7 is 63. 9 times 7 is 63. 9 times 8 is 72. 9 times 8 is 72. 9 times 9 is 81. 9 times 9 is 81. 9 times 10 is 90. 9 times 10 is 90. 9 times 11 is 99. 9 times 11 is 99. 9 times 12 is 108. 9 times 12 is 108. 10 times 1 is 10. 10 times 1 is 10. 10 times 2 is 20. 10 times 2 is 20. 10 times 3 is 30. 10 times 3 is 30. 10 times 4 is 40. 10 times 4 is 40. 10 times 5 is 50. 10 times 5 is 50. 10 times 6 is 60. 10 times 6 is 60. 10 times 7 is 70. 10 times 7 is 70. 10 times 8 is 80. 10 times 8 is 80. 10 times 9 is 90. 10 times 9 is 90. 10 times 10 is 100. 10 times 10 is 100. 10 times 11 is 110. 10 times 11 is 110. 10 times 12 is 120. 10 times 12 is 120. 11 times 1 is 11. 11 times 1 is 11. 11 times 2 is 22. 11 times 2 is 22. 11 times 3 is 33. 11 times 3 is 33. 11 times 4 is 44. 11 times 4 is 44. 11 times 5 is 55. 11 times 5 is 55. 11 times 6 is 66. 11 times 6 is 66. 11 times 7 is 77. 11 times 7 is 77. 11 times 8 is 88. 11 times 8 is 88. 11 times 9 is 99. 11 times 9 is 99. 11 times 10 is 110. 11 times 10 is 110. 11 times 11 is 121. 11 times 11 is 121. 11 times 12 is 132. 11 times 12 is 132. 12 times 1 is 12. 12 times 1 is 12. 12 times 2 is 24. 12 times 2 is 24. 12 times 3 is 36. 12 times 3 is 36. 12 times 4 is 48. 12 times 4 is 48. 12 times 5 is 60. 12 times 5 is 60. 12 times 6 is 72. 12 times 6 is 72. 12 times 7 is 84. 12 times 7 is 84. 12 times 8 is 96. 12 times 8 is 96. 12 times 9 is 108. 12 times 9 is 108. 12 times 10 is 120. 12 times 10 is 120. 12 times 11 is 132. 12 times 11 is 132. 12 times 12 is 144. 12 times 12 is 144.